Hello, I am the Ronan Paul, and welcome to a twitch.tv/Ronan Paul livestream on twitch.tv/Ronan Pawn. Welcome back to the show. It does go on, is what I've heard. I've been missing for the last week. I took 2 live streams off. First live stream was just a little bit too close to an MECFS kind of event. Oh, one of my webcams is down. An MECFS kind of event that I had. And so I was taking a little bit of time off until I recovered. The next one came around, and my buddy Brandon had been out to work on the house. And so I had just been very physical, very on my feet the day before. Not so much helping Brandon as pointing at things and, having him show me stuff and me saying, well, maybe like this. But yeah, both live stream days I just felt like, for the sake of my health, carrying around myalgic encephalomyelitis with me, best bet would be just to take those days off and recover and not have any major flares or events. And I can happily report I did not have any major flares or events. What I did instead is I did a lot of programming. And ladies and gentlemen, boys and girls, that's what we'll be doing today. Join me in the new coding workspace, which is just my desktop. my real desktop. Not the fake desktop that some of you still think is real somehow, that this is like... that I've configured my... my actual real desktop, which is this one, but we've got a coding workspace, and that's going to look like this. And yeah, this is the setup for the live stream. In case you ever wanted to see behind the scenes, I've got Reaper over here, which is doing some inline processing on my microphone, in case you want to find out what I sound like, well, what the microphone makes me sound like without the inline processing. This is pretty bad, isn't it? This is not up to snuff for what our audio standards are. I presume. I can't actually hear what you're hearing when I do that, but I turned off the effects channels, so I presume that's what you're hearing. I also keep over here my this is AIMP, which was the best Winamp-like media player I could come up with. It's a little bit dark, it's a little bit small, I have issues with it. I'm going to write my own in Python, a little MP3 player. That's my intent. After I finish the project we'll be working on today, but you can see here I've got the live stream music in one tab ready to go. In another tab I've got the break music, which is just, my recordings over the years. This is how I'm set up, and then on the other screen that you can't see, I've got OBS in an incredible configuration that if you saw, you'd be like, I had no idea that OBS can do that. But you can't see it, so I won't allow it. Can I just do this, actually? Can I just do like that? And that's my OBS setup. That is the kind of configuration you can give to OBS if you sit here for like 2 hours fighting it, because it's actually really horrible. OBS uses Qt, and there are problems here. If we go into view, you'll see, is it view? There's something here. Docs? Full height docs. Full height docs. You have to choose whether or not, this is how bad this system is. You have to choose whether or not you want the system to be locked on the horizontal or locked on the columns. And then if you lock it on one of those axes, you can sort of break it out of those axes as well. It's brittle, it's a mess, and the moment that you click this button, you wreck whatever you've set up. So I've got my setup backed up in text files because OBS is so brittle with its actual configuration. But this is my desktop. This is what she looks like. This is the zoom level that I'm on. Remember, I'm living from a twin-size mattress here, and so my monitors are about 8 feet away at the end of the bed. 32-inch, the one that you're looking at now, and then the OBS one is 27, I think. Both 1080p, and the operating system is zoomed to 125%, and so when we open up PyCharm, you'll see that actually we're going to go into an extreme zoom for the sake of this. So this is the zoom at which I'm usually doing my work around here. And this is what I'm comfortable with. But for the sake of the live stream, I feel what we should probably do is switch into presentation mode. And that's just going to be a lot more visual for you guys. A lot more like right at about the right size. And I've just brought up down here the run dialog, which I keep on the second screen. I can still see chat, and I can monitor the live stream and everything. But I've got an overlay. Dramatian with the 72 months? You just do the math on that. Hang on, let's find out. So 72, that's an 8. 72 divided by 12. That's almost a year. Holy shit, 6 goddamn years. You've been throwing money at my face on a more or less monthly basis. Thank you so much, Dramatian, for these 6 years of continuous support here on Twitch. I hope you got a deal. You didn't, because it's September or whatever. And but new subscribers, I think the way this works now, September has just gone downhill since they first came up with it. You know, now that they've got the audience and they've got the streamers, they got the people here, and nobody can leave. You're married to the platform. September went from being like, oh, it's 50% off for everything, to maybe it's 50% off for just new people, to now it's like, we'll give you 25% off if you subscribe for an entire year and you've never subscribed to them before. Like, I don't know what the standards are for September at this point, but it ain't what it used to be. It sure ain't what it used to be. But thank you so much, Dramatian, and happy birthday for 6 years of subscriptions, man. 72. You know, what's crazy is that at this rate, so long as I manage to not die, we will end up with subscribers who have been around for 3 digits. Here we go again! 3 digits worth of time. Dramatian, you've been around long enough to have seen me code in Python previously on the live streams. This is the first time in years that I'm going to be doing any live stream coding, so I expect no one to show up. Thankfully, I will have no idea whether they do or don't, because I don't monitor. I have no way of monitoring how many people are watching the stream in my current rig. But yeah, I expect no one to show up, and you know, for the best, because they're intelligent, because my viewers know what's best for everyone, really. But so this is my, this is, by the way, this interface, this presentation mode is not anything that I usually use. I got into this last night for the sake of the live stream to figure out what we could do to make this look nice. But so this is my project. This is called GUIable, is what I have called it to date. I may change the name when I finally get to a release point for the second version of it. It actually is available here and now today if we pop open some ungoogled Chromium and we head over to github.com. No, not never decaf. Ronan Paul. Oh, there it was. Get over to GitHub. We'll see that GUIable is available today. Is this GUIable too? Yes. There's a branch. So there's the main branch that's, you know, years old now. I started this project in 2019 and then obviously, you know, walked away from it. I got to a certain point, a stopping point, used my own code to build some applications, and then I was done with it for a while. I've come back to it, and I'm now working on the second version of it, which is incredible. What I have accomplished here is goddamn insane for what TK, the underlying GUI system, the underlying window management interface, operating system, whatever you want to call it, the underlying window system can do, and what Tkinter, which is the Python internal framework for communicating with TK, what these two things can do combined, what I have squeezed out of them, is more than the maintainers probably ever dreamed was capable of either TK or Tkinter, and I will show you that today. But I wanted to share with you, first off, that it is available. You could, you know, look at the code and, you know, make a poll and futz with it yourself, if you wanted to. here and now today on Ronan Pawn, github.com/RonanPawn/GUIable, and then, look for the correct branch, which this branch is 57 commits ahead of the master. I always forget how to navigate GitHub. This is a very neckbeard website. I'm going to start using this word that I got from a troll in chat, actually. And they weren't describing me, I was talking about Linux, and they were saying, well, you picked a neckbeard distro, so that's what you're going to get. I love the word. I banned the viewer. Neckbeard. This is a very neckbeard website. Like, GitHub is not made to be used, and that is basically the Linux mentality. The Linux mentality is we make things so that the things work, not for anyone to be able to actually use the things. They won't be intuitive. You won't be able to walk up to it and make sense of it. We're going to make, for example, the regular expression system, regex. Have you ever seen regex? It's fucking hieroglyphs, and the people who use it have no idea. They have to, you got to go to a website and type in what you want, and then the website conforms it to what you need to use in order to use regex. It is a system made by Linux people. Linux people give two shits about intuitiveness, about just being able to communicate with another human being, about someone being able to walk up, open your application, and know how to use it. Linux folks don't give a damn, which shows through in their pathetic attempts at making desktop environments on top of a system made for headless environments. Where is the payable code? Says Jermasian. I don't know how to monetize this one. I've been very, loud about the idea of don't work for free. I don't know how I could possibly monetize this. This is me working for free. If I can figure out a way to monetize it, then I will, but I can't figure out a way to do it here. So, anyway, it's available, it exists. Don't go check it out because I'm about to show it to you. So before we, actually look at any of the code, let's just start up sample 1. Let's just start it up and have a look at it right here, right now, what the state of the code is today. So right here, right now, watching the world catch up to its history, what we have in GUIable is, I have made TK fully transparent, transparency supporting anyway. I support transparency between sibling widgets. Everything is basically a widget. The widget is like the broadest term that you can use in the library and in TK to say that's a widget, that's a widget, that's a widget, these are widgets, that's a widget, that's a widget, the background is a widget. Everything's a widget kind of a thing. So what I have from the starting point here is I have enabled transparency in Tkinter, which it doesn't support. There is no transparent graphic support in TK. That's not true. Okay, so the photo image class supports transparency. What TK does not support is transparency between widgets. So you can't have like a label on top of something else and then have the label see through to the graphical background of the thing that it's attached to. At least in the core original library. There might be something in TKK or TTK library that does that for certain elements, but generally speaking, you can't get what you are seeing right now. You cannot get one thing to go over the top of the other in TK or in Tkinter. You might have noticed that this passed under and you're like, oh, that's a bug. That's not a bug. That proves that you can make a widget that is completely and totally transparent, that has no skin to it, and it'll just see through everything. That's why this is here. What it sees through to, though, is it sees through to the background that it is on, and it sees the siblings that share that background with it. So when I drag it over this, you'll see pretty much nothing. You'll see like the part of this that's a little bit of a bug we got to look into. Probably not today. But you'll see nothing happening until I go over the text, because text isn't graphics, so it can't be blitted to the surface of something. This is the way that I'm doing this, in case you're wondering. How is he accomplishing transparency in Tkinter? what's happening here is these are all canvases. So it's just a square. And then what's happening is this guy is, as a square, he's saying, okay, where am I on top of my parent? And does my parent have a background? It does? Okay, I'm going to copy the back of that, what my parent has, the graphics, from underneath it, and I'm going to draw it on top of, I'm going to draw that as the basis of my surface. And then I'm going to draw me on top of that background. So every time, as I'm moving this thing around, it is drawing the background first and then drawing itself on top of it. When it comes into contact with the siblings around it, it then has to add, it actually expands the job, the blitting job, the copying job. We call it blitting, but the duplicating job, so that it's pulling in, we create a canvas, another canvas, a logical canvas, a logical space where we've copied all of the space where all of the siblings that I'm touching can live in, and then we copy each of them to that, paint their surfaces back to them, back to themselves, and so when this is over top of these three other widgets, we are drawing the background, and then we're drawing this widget, and this widget, and this widget, and then we're drawing this widget on top of it. And it's all happening at the rates that you see popping up in the run dialog down here to the right. When I drag this around and it's on an empty space, you see we're drawing, and this is because we're on the live stream, at a 0.004, so 42 hundred thousandths of a second, I think is the correct way to read that. It's 4 10,000ths of a second, but if we wanted to do 42, then it's 42 hundred thousandths of a second. When we're not live streaming, you can take a whole 10,000th of a second off of that. It's more like 3 10,000ths of a second instead of 4. But that's when there's nothing else to draw. When I get over the top of 3 other objects, you see that it takes longer to draw them because we're having to add all of these other draw jobs into the job. So we get up to 0.05. I don't know what that just was. That's a pretty big bump right there. But yeah, that's where we get to that. When I go under widgets, it's even heavier. It's even harder on everything, and because we're on the live stream, we're actually up to 1 full thousandth of a second at this point. And we're still fine at 60 frames per second. But because now I'm under these widgets, what's happening is, why is this worse? We have to draw the background, right? But then each one of these things has to like draw itself and what's under it, is kind of how this ends up working. It's no longer me. When I'm on top of something, I can just say, draw these widgets to my surface, right? When I'm underneath something, I have to ask those widgets to redraw themselves containing me, because I'm underneath you now. So you have to draw the surface of you have to draw your background, then you have to draw me where I am in your background, then you have to draw yourself. That's the craziness of what's going on here in order to, achieve this. And you might be able to tell, we're on a live stream, extra heaviness. There's no, this is smooth. This is beyond 60 frames per second is what we're seeing right now as I'm doing this. You can't see all the frames. It probably looks worse for you than it looks for me because you can only see 60 frames per second. So that's where we've started, is I have transparency supported. As you can see, I've got states supported, and I've got them supported to the point where we've got a toggleable, in GUIable, everything that's core has been called something able. It all is suffixed with able. So this is a draggable. This is just I think this is actually a pushable, is what that's considered, because it's a button. And I'll show you the difference. Like here, this is a clickable, and when I click it, it clicks instantly. I haven't released the mouse button yet, and it clicked immediately. Buttons don't usually work like that. A button works like this. You click on it, and it doesn't do whatever it's supposed to do until you release the button. And if you move off of the button and then release, it doesn't do it. So we call that a pushable. And I'm using a lot of air at the beginning of the live stream here to talk about this stuff. So maybe I need to slow down a little bit for the MECFS-ness of me. But so this is a clickable. It clicks instantly. This is a pushable because until you release, it doesn't fire. This is a draggable. This is a labelable, which is I just whipped that together. That class has to be completely rewritten. All these are labelables. And then this is a toggleable, and a toggleable has extra states because, your average pushable has its normal state, where there's no interaction. Then it has the hover state. I'm now hovering over the area, so it changed into its hover state. Then there's the clicking state, the active state, and then there's also a disabled state, which I can show you right here. This is the disabled state for this scroll bar because we don't need it, so it automatically disabled itself. So there's 4 de facto states in my library: normal, hovering, active, and disabled. And then what a toggleable has is it has double the number of states, because we have a normal state, a hover state, an active state, and then we have a normal true, hovered true, active true, and then back to the false version of it. So there are actually 8 states for this. There's disabled, active, or disabled true, disabled false. It's all in there. So that's what we've accomplished basically. Those are the basics of this. What the big challenge that I have pretty much defeated here quite happily of building a system like this is the scrolling. Scrolling is so much more complicated than anyone who has never tried to write it thinks it is. There's a lot of little, not too complicated algebra involved, but there's a lot of it. And the issue is the relationships between everything. So this scroll bar handle needs to represent the size of the content that is that is scrollable here. So right now, in fact, let's go to the code for the first time. Let's go to sample1.py. Somewhere in here down at the bottom, I'm making 50 labels in there. Let's take that down to 14. Okay, and then I'll restart the application. See the handle size now? The handle size is representative of how many labels there are, like how much content is in the frame. That's how, your average scroll bar works and looks. It represents, like how much of the space is left to be scrolled is basically what is happening here. So when I scroll it, and we're about to see scrolling work for the first time, and look at buttery smooth goddamn scrolling. I'm a goddamn genius, I'm telling you right now. So this relates to the size of the content within here, but it's the size of the content within the size of the frame that you can see it through. There's a lot of relational math going on, and the problem with doing this in TK is that geometry updates whenever the fuck it feels like it. In TK and Tkinter, you are not guaranteed to get live geometry that is true. And if you want to get it, you have to do things like force an update of the idle tasks. But every time that you do an update of the idle tasks, you slow down the application because you're basically waiting for the next cycle to come up. And so everything else that might have happened gets parked behind that, waiting for the next thing, or at least it can, depending on how you write it. So it all becomes very tricky, making sure that all of your data is accurate, that you have single sources of truth and stuff. Can you drag the scroll bar yet? It says, Nura, indeed you can. So first off, and here's a bug. Note that when I click this, you see the the label up there for the end cap of this trough moves over. That's a little bug. And the weirdness of this bug, if I restart again, is if I click one of these first, Okay, and look at this. If I click one of these first, the handle goes down to its smallest possible size, but then when I hover it, it goes back up to the normal size. I have very good ideas why that is like that. But now that I've done that, look, now there's no problem. Now the bar doesn't. That one's going to be a tricky bug to find. But can you drag the bar? You absolutely can drag the bar yourself. Just grab it by the handle, move it up and down, and then you might be wondering, why is there like double arrows here? And that's because these are single line scroll buttons. It's kind of old school, but in old school computing you would see this a lot. In the scroll bars you would have the main bar, but then you'd have buttons at the end of them, and when you clicked that button it would do a single line scroll. I've just configured these to be instantaneous, animated, smooth scroll line stuff recently. And then this is another draggable that I just threw in here, and this is to prove that when you change something that's in the frame and you leave the frame, you come back in, it's where you left it. And you might think to yourself, well, of course it is. But no, not of course it is. No, friends. It is not a foregone conclusion that this would be where I left it when you scroll away from it. And I will show you why a little bit later, because of the genius of how I've done this. Here's the genius of how I've done this. That was 14. I was set to 50 before. Let's do 1,000. It's going to take a minute to spool up 1,000 internal items here. So I now have 1,000 items from here. 1, 2, 3, 4. Keep counting and going down. How slow do you think scrolling is going to be when there are 1,000 items in the list to move? It's exactly the same speed as if there were 14, 8, 50, or anything else, because I'm a goddamn motherfucking genius. It's smooth as butter. You can drag it all the way to the bottom and there's no delay. It's smooth as a motherfucker because I'm a goddamn genius. TK cannot do this. Tkinter cannot do what I am showing you right now. If you use the standard methods that TK and Tkinter provide, you cannot get this kind of performance. But I'm a goddamn genius. And I'll show you now. I suppose we've kind of come to the end of my goddamn geniusness. I will show you now why I'm a goddamn genius there. So let's head over to Scrollable. And let's do... What would show this? We're in Scroll by Click, okay. Scroll by Drag, Scroll by Click. Move Plate. So... the way that, let's go back here just for a, demonstrative. All right, it loads 1,000 things now. I need to change that so it doesn't do it again. The way that this works, usually, is that you have your frame, okay? And so this would be the frame, not including the scroll bars. This would be your scroll frame. And the frame becomes the boundaries of, the viewable area. It's like what you're looking through the frame of a painting to see the painting underneath. The painting underneath is what I call the scroll plate. And I call it the scroll plate because the plate has all of these things on it. Your sushi, your hors d'oeuvres, your hors d'oeuvres are all on the plate. And then when you scroll it, the plate moves. It moves up in order to have, to go down in the list kind of a thing. So all this stuff is attached to the plate, and the plate moves. The way that you would usually set up a system like this in TK and Tkinter is exactly like that. You would have, TK has a thing called a frame, a tk.frame. Right there you can see I use that class in my class. You would use a frame, and then within that frame, you would probably have, like, another frame. Yeah. And then you would attach everything to the inner frame, and that inner frame would be your scroll plate. Excuse me for a minute, I'm going to grab a drink. So you would attach everything to the scroll plate, and then when it was time to move... when it's time to scroll, you would just move the plate, And then implicitly... Uh-oh. What did I do? That's fine. Implicitly, all of the children of the plate would get moved because they're attached to the plate. And so TK would go through every single one of these items, and it would move it with the plate. It would do the math to move it. Even if it's not drawing it, it would keep track of where they are, you know. What I have done that is so genius is I have no scroll plate. I have just a scroll frame. And so when we say move the plate, I'm calling my frame's plate geometry. This is entirely logical. This is imaginary, is the better word for it. The plate is imaginary. The plate is basically just its geometry, which is just its XY coordinates, and then its width and its height. That's the geometry. And that's all that a plate is in this system, is a list of 4 integers. Using that list of 4 integers, what we do is we accept the delta of change that you want, the change in position that you want. You want it to move on the Y 5 pixels up. Well, then that's -5. Is that right? Yeah, -5 to go up. You want it to move down, 5 to go forward. We accept the delta, the change of pixels in the direction, and then we take those pixels, and for every single child that is in the skull, the frame, because there's no plate, the children are attached directly to the frame, we move the children individually. And we don't move them if we don't have to, so we parse them individually. So I get the child's geometry, which, by the way, is an internal value that I have manufactured and keep track of because TK's geometry is too slow to update. You don't want to keep polling WInfo things in TK. It's going to slow down your whole application. So we get it once, and we keep track of it, and we only update it when we have to. We get the child's geometry for every single one of those labels that we see in here. Let me pop back over to the sample and reduce this to a reasonable number. 50 was fine. And then back over to scrollable. For every single one of these, item 1, item 2, item 3, okay, we get that child's geometry. Where's item 1, where's item 2, where's item 3? And then we ask the question, is that child, we check if the child's rectangle, its geometry, overlaps with the visible plane of the frame. In other words, can we see it? Can we see, should it be drawn right now? Is it in a place where a portion of it needs to be drawn? And if that's true, then we update its geometry with the delta, with the changes, and then we draw it. We replace it, and then we redraw it. If the other thing that we're asking is, so we've got live, which says whether or not it's currently visible. But then we ask again about the recs overlapping to say, is it becoming visible? So if it's already visible and it's staying visible, well, then we just draw it and we move on with our lives. If it's currently visible and it's going off screen, then we actually move it to a special place. We move it to 0 on the X and then the negative of its own height so that it's just every single one of these. This is what's crazy about this. Look at this, okay? I'm going to scroll down to the bottom right now. Everything from 42 up lives right here. It's all stacked on top of each other right there, just off screen at 0, negative the size of itself. So it's always going to be right here. And if it's something bigger, then it'll just be 0, the negative the size of itself. It's just living right there. They're all stacked on top of each other. And we're not moving them. We're not considering them. We're not doing any math on them. We stacked them up there, and until they move into a space where they would come back on screen, we've just forgotten about them entirely. But the only consideration they get is every time that a scroll event, every time that the movement of the plate is requested, we run through the entire list of them and we ask them this simple question. Is your scroll XY right here, is your scroll XY, which is your, this is your logical position on the plate. Okay, remember the plate is imaginary, and then the child is being pushed off to a spot right over here and just left there. So we need to track where it's supposed to be on the plate. So this one started at 0, 0, right? But now it's wherever the hell we left it on the plate, which is right there at this moment, kind of a thing. When we come back up to it, it needs to be put back to 0, 0. So we store that value away, which is why earlier I said this exists here to prove that when you move this to a different location and you go off screen, that just got moved up to here because it's no longer visible. So it's sitting up there right now where you can't see it. But when we come back to it, it's right where you expect it to be. This is the genius that enables me to put 1,000 items in my list and have the same performance as if I have 8. Because I'm only ever moving what is on screen. And so the limitation of my scroll panel here is how many items are visible. Not how many items are in the on the plate, because there is no plate. The plate is a lie. Fuck the spoon. The plate's a lie. The limitation is how many things are visible, and at the rate that we're currently drawing, we've got that down here. You can see in the run dialog there. At the rate that we're currently drawing, which is about, when we're not live streaming, it's 3/10,000ths of a second. Okay, so get me this out. Get me a calculator out. At 3/10,000ths of a second, okay, what do we want our refresh rate to be? And what I've chosen is 60 frames per second for this. So at 60 frames per second, if we do 1 divided by 60, 60 frames per second is, this is in milliseconds, you would say that that's 16, or you would say that it's 17. It would round up to 17 milliseconds. So if we have 1 frame every 17 milliseconds, okay, and it's costing us 3/10,000ths of a second to draw each thing, then we would do 17 divided by 0.3 milliseconds. So 0.3, yeah, 0.3 milliseconds is 10,000ths, those are 3/10,000ths. And that gives us 56 items that we can have in here being drawn in each frame before we are trying to draw more than we can draw in the amount of time that we have, which is 17 milliseconds. We can draw at the current rate about 50 to 60 items in this scroll window. And so the question becomes, how many items are you ever going to be able to, how many items do you plan to have on screen that are transparent? The reason it takes this long to draw them is because they're transparent. Every single one of these is looking through itself to the background and copying that background to its surface, and then drawing the image that it's got there to its surface, and then writing the text over the top of it. Every single one of them is doing that every time we do a scroll. And in addition to that, we're changing the scroll bar color, and we're moving this guy. We've got basically 50 movements, or 50 redraws that we can do in a single 60 frame per second frame. And I actually was running this. If I go to where our smoothing rate, which is just the frame rate at this point, I was running this at 8. I was running it at what is ostensibly 125 frames per second. I started up like this, and if anything, like it looks worse right now because it's starting to struggle, right? Doesn't it kind of, to your eyes? It's starting to struggle, and it might not, I don't know, maybe it's not starting to struggle at 125, because we're only drawing 8 things, so I don't think it is starting to struggle. I think it just looks bad. You have to bear in mind that there is no easing in a system like this. There's no, like, drawing a middle frame that kind of is blurry or something like that. This is all pixel math. Everything has to snap to the pixel grid of the screen, the way that this is implemented right here. So it actually, in my opinion, I mean, I would go with this 60 frames per second just because it gets you so much more overhead before you're ever going to, like, you're never going to run into a problem having 60, you're going to have 60 transparent objects on the scroll plate at the same time. No, you're not. No, you're not. And things are going to get better, hopefully. I'll be able to find little enhancements and optimizations as I get closer to the end of this project. But that is the method by which I have made TK scrolling actually just not give a damn, and I might just do it again to, take my little victory lap here on the live stream. It just doesn't give a damn. Let's go up to 500 items. We did 1,000 earlier, so I don't really have to. 500 items, and the scroll rate is the same. The smoothness is the same. It looks exactly as it did when we were scrolling 50 to scroll 500. This system does not care. It actually has, culling. It has proper culling, which Tkinter, a graphic system for putting windows together, for making windows in operating systems. TK was first released in 1991. They're still using it in Python. It still ships with Python as the default GUI, and no one uses it, and no one knows how, and it's because the potential has never been tapped. And I'm finally tapping it. I'm calling it in. I'm tapping it in. Tapping that ass. But so that is, I've just, over the course of the first, how long has it been? 40 minutes of this live stream. I've introduced you to what I have already achieved here, and I've shown you some of the bugs that we're dealing with. So today, what I would like to do with y'all on the live stream, and can I get rid of that? I can just do this for the moment being. There's some things in particular that I would like to tackle with you today. Let's go down the list. If a parent changes, so if its geometry or the image that it draws to itself alters, all of its children should redraw themselves. We need to make sure that that kind of thing gets propagated. I think it is being propagated, but it's like being propagated by a bunch of little, I shoved in code here and there to make it work, as opposed to having it at the core of the library. So I want to go to the core of the library and put it where it's supposed to be. That's one of the things I'd like to knock out. Another is fix the bug where a repeatable state can remain locked in hover or active. So let me see if I can't show you this bug. So first let's do this so we don't have extra bugs going on. If I scroll up and then I scroll down, right there, boom, first try. So right now it's locked in the active state. I'm not holding the mouse button down. If I were, it would be scrolling, but the image got stuck in the active state. It didn't update again to its just hovering state, which is really weird because, when we do it up here, I don't know if I'm able to make it happen. If I click here and then, yeah, when I'm above it, it doesn't seem like I can make this happen. But when I click above and then come back down below, I can trick it into that state. I've got a pretty good idea where that bug's going to be. So I think we should be able to bang that out pretty quick. And then we get to a really fun bit here, if we can get there. Which is working out the math for conforming the delta of pixel movement, the duration of an animation in its milliseconds, and the frame rate of the animation to a prepared set of animation deltas. And maybe you can hear my neighbors yelling at each other. That's just how they communicate. They do it pretty much every day. Through my open window during the live stream, these fucks. So working out the math for conforming this stuff. So this is a really interesting situation. Right now, if we go ahead and pull this back up, right now, when I click this button, the way that we're doing the animation, the way that I'm doing the animation right now, is we create a list of all of the animation steps, and then we execute those steps. So let me show you that. Go back over to scrollable, and where will this be? This will be Not in conform. Let's look at the let's type animate. Begin animating. So animation step. Let's do begin animating, and right here I'm going to put in a print. Print the step list. The step. Oh, the self.step list. Thank you. Alright, so run that bitch. And then when we click this, watch in the run dialog box down here. This is what gets created. And it's running off screen for you guys, but it goes for like a page scroll goes for 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 steps plus the 0, plus this guy on top of it. I'll explain that in a moment. But when I do a scroll, there's one that fits on screen. It creates the list of deltas to push into the move plate function that we looked at earlier. So you want to go down, then -4, -4, -4, because that moves up, that moves the plate up. You want to go up, then 4, 4, 4, 4, 4, 4, and we do 3 frames worth of animation plus the 0. Why the 0? The 0 is so that when I hold the button, we are in a continuous state of animation. So we run the 4, 4, 4, but then we get to the end of the delay, and we fire a new event, and that new event happens before we get to the actual end of the list, because we're popping these numbers from the end of the numbers. We're going, we do this 4 first, and then this 4, and this 4, and each time that we do it, we pop one off. We throw that away. We take it off, we get the value, and we throw it away. Then we get the value, and we throw it away. We get the value, and we throw it away. And we keep doing that until there's no more values left. So by having a 0 in here, it means that we're still in a state of animation when we come to the end of the animation, and when the next animation, cycle is requested. So when I do a holding the page scroll like this, and it just moves smooth and there's no stutter, that's because we're interrupting our own animation cycle as it would be firing the 0 to just add more steps into it. That's why I've done it that way. Problem is, okay, here's the problem. When I click this, you see we do 3 steps, and each step is a value of 4. So then we move 4, 8, 12 pixels. Here's the problem. I have requested 14 pixels. I asked it to move 14 pixels for the line size, line scroll size. But the way that we're doing the math right now, it's impossible at 17 milliseconds, at a 17 millisecond frame rate, within the amount of time that I've specified, which is down here. I've said, do the animation across 50 milliseconds. It's impossible to do the animation in 50 milliseconds on a 17 frames per second timeline and end up with 14 pixels at the end. You just can't do it. Except to do one step of 14, and then there's no scrolling going on. And so the math right now breaks our units down and conforms them, and it ends up changing both the delay and the line size in order to get them to something that's close to what we asked for. And that is not good enough, friends. That is not good enough for me. Because you need to be able to, in my library, in my house, you need to be able to ask for a specific movement of delta, a specific delta of the pixels, a change, and get that amount that you asked for. It's important that a developer be able to have confidence that they can say, I want this to scroll 15 pixels, and it needs to scroll 15 pixels. Now, what is less a priority is that it do so in exactly the amount of milliseconds that you declared. That is less of anyone's interest in a user interface. When you set a millisecond delay in a user interface, you're just trying to make it look nice. You're not trying to, there's not a scientific reason in a UI to have it at 52 milliseconds instead of 51, except to try and make it look nice. So what I want to do today is I want to resolve this problem. Back over to the to-do. I want to resolve this problem with a solution that I've worked out, and I worked it out thusly. First, I wrote down what my desired result was going to be, and I want the animation returned must always result in the exact pixel delta requested. No, I will not let you conform that number at all. The millisecond duration requested may be altered to conform to the frame rate. You can change how long it takes. The animation may utilize 2 delta values to achieve the result. Those delta values must have a difference of no more than 1 pixel between them. So what I'm saying is you could alternate numbers, but those numbers, they got to be right next to each other. I'm not going to have it stutter and jump and, 1523, 1523. It's got to be one right next to each other because we're doing pixel math and it's going to be a visual result. And we want to get the best visual result that we can get. So how do we get there is the question. And the answer that I came up with is I proposed some sample cases. If we have a frame rate of 17 milliseconds, all of these are going to be 17 milliseconds, which is 58.9 frames per second. It's the closest to 60 frames per second without going over. If we request a delta change of 14 pixels like I'm doing now, and we request a duration of 50 milliseconds, then the result that I want is conform that to 51 milliseconds, which is divisible by 17, which is 3 steps of animation, and then give me 455 to equal 14 pixels. If I were to ask for a 205 delta at 160 milliseconds, well then conform 160 to 153, because that'll fit the 17 millisecond frame rate. 153 is 9 animation steps, and so with 9 animation steps, and you want to get to 205 pixels, the issue becomes, when we do division on stuff like that, calculator out, let's see if I can remember how this works. The issue becomes, you want 205 pixels worth of movement, and you want it done in 9 steps. Well, we can't do that with an integer. We simply cannot get an integer back from that. But we can get 22, and then, hey, what's 205 mod 9? 7. So 7/9 is what the mod value, if you're unfamiliar with mod, it's when you do division, you would have like a remainder. 7 is the remainder. So we're saying that 22 and 7/9 is what we get when we do 205 divided by 9. 22 and 7/9. It's just, represented. If we represented it fractionally, it would be 7/9. So what we can do then is we can have 2 22s and 7 23s, and that adds in the 7 of the 9 that we're missing in order to get to 205. And I'll show you. 22 times 2 is 44, plus 23, 23, 23, 23, 23, 23, 23, and there we are. We hit 205 immediately. That's the premise behind this. Take the remainder and add it to the baseline of the what do I end up calling it here, actually? The root delta. The root delta is 22. That's the floored division. That's the whole number. And then you take the mod of that, the 7/9, and you add 7 more of 1 extra to it, and you'll be able to land on exactly the pixel value, which was, the thing that I said has to happen here. And the only question is, how do you want to position those values in there? If there's 7 23s and 2 22s, is this how you want to do it? With 1 at the end and 1 at the end and 23 in the middle? That's an idea. Okay, last example. You want 93 pixel movement over 100 milliseconds. Conform the 100 to 102, which is divisible by the 17 frame rate. 102 divided by 17 is 6, so it's 6 steps of animation. And 93 divided by 6 steps gives us 3/6. Okay? The remainder is 3/6. The mod is 3, and the number of steps is 6. So in that instance, we want this to alternate. We don't want to stick all the 16s at one end and all the 15s at one end. We want to go 15, 16, 15, 16, 15, 16. That'll give us the most consistent visual appearance of a steady animation rate when we animate it. Give me a moment to take another drink and catch my breath again. As the cops track me down in their helicopter. Maybe I'll grab another Tic Tac too. So, I've described for myself what it is that I want in terms of results. The question is, how do we get there? And in the process of explaining it to you, I've explained how I figured out how we get there. The duration is conformed to a number of steps by simply rounding the duration divided by the frame rate. So that's where we took the 205 and we divided it by 17 in order to figure out that it's 9 steps with a little bit. We rounded it. So it was 160 divided by 17, which we ended up with 153. So that means that the actual delay becomes the number of steps times the frame rate, which we turn that into a 9. 9 times 17 gives us the actual amount of delay, which is the 153. The root delta is found by floored division, so the delta divided by the steps, dropping the remainder. And then we get the excess delta by the mod, so delta mod steps. And then if the mod is half the number of steps, then we want the steps to alternate. That's where we saw the 15, 16, 15, 16, 15, 16. In all other states, this is what I decided after some consideration. The excess delta should simply extend the list. So, this is the pattern. We go 1, and then 1, 1, and then it looks a little like binary, but it's not quite. 1, 1, 1, and then 1, 2, 2, 2, 1, 1, 1. When we get to this situation, 1, 1, 2, when we're just adding a single 2 in, we add it to the right side. We always add to the right side, in fact. So we're just going to split. All of the 1s go on the left, and all the 2s go on the right. So when there's 2 2s, then they're always on the right there. And so we see the only time that we don't follow that rule is when we can alternate them, when it's an even number of spaces, and the number of excess deltas is half that of the total number of steps. All the 1s are on one side, all the 2s are on the other side. All the 1s are on one side, all the 2s are on the other side, all the 1s, all the 2s. This is actually the second system that I considered. The first one I considered was this guy. The excess delta is filled middle out, favoring the right side of the list. So what do I mean by that? I mean this. I mean when you have 5 steps and you got to put 2 2s in there, which side of the middle do you put them on? You put them on the right. I came up with this idea because I was thinking that if you are fast in the middle, then on a single click, it'll kind of look like easing. It'll look like you sped into the middle and then slowed down at the end, and that's a very smooth looking animation. But the simple fact is that you're not really going to be able to see that difference at a single pixel's difference on a single click. Where you might notice the difference is when you are holding the button down for a continuous scroll. When we have this up and I just hold this continuous scroll like that, you might notice the change in delta there. But there, it's not really going to make a damn bit of difference whether or not these 2s are in the middle of your logical animation cycle or whether they're at the end of your logical animation cycle. It's still just going to be 1 1 2 2 2 2 2 1 1 2 2 2 2 2 1 1 2 2 2 2 2, whether it's 1 1 2 2 2 2 2 1 1 2 2 2 2 2 or 1 1 2 2 2 2 2 1 1 2 2 2 2 2. So it doesn't make a difference, and this is just easier to do. Rather than come up with some crazy logic to fill from the middle out, favoring the right side, just have all the ones on the left and all the twos on the right. That is the big job that I would like to tackle here today with y'all when we actually get into doing the code. The other things that are on the immediate to-do list that we probably won't get to are to figure out why Barskin is behaving so badly, and you can see the instance of that right here, where when I mouse over, or I have to explain what a Barskin is, huh? This is a Barskin. The trough here is a Barskin. Technically this is a Barskin, but you can't really tell. But the idea behind a Barskin is that it draws a cap, an end cap, and then it draws a middle repeating, flood filling, tile filling actually is what it's called, tile filling, as to whatever height you declare or whatever width you declare. To whatever length you declare is what I call it. I call it length and breadth so that we don't have to be tied to whether it's a vertical or a horizontal. But so whatever length you declare, it draws the trough, and it goes cap, trough, cap. And so that way you can have an infinitely extendable graphic that we can change the size of for the sake of something like a scroll bar, or for the sake of something like a handle, which changes in length depending on how many things are occupying the scroll area, the scroll frame. So now this is this long, and if I had a graphic attached to it, we would have the end cap here, and then the middle would get drawn in those areas. That's the concept behind the Barskin class, and you can see here that it's not behaving correctly or consistently. In fact, between the last time that we opened the program, that we ran it, and this time right now, it's now only doing this issue on the active state, but it's not doing it on the hover state. In the last one, it was doing it on the hover and not the active, and if I restart it and I make sure and click U first and then mouse over U and then come down here, then it won't do it on any of the states, it'll behave correctly. So there's some weird shit going on with Barskin in general that I need to dig into and figure out what the hell it is. That's going to be tricky. And then this thing's just been on the list, the to-do list, for a while now, to implement instant scrolling and smoothed instant scrolling. So the idea of instant scrolling is instead of clicking and then having it move in a page to where you're going, instant scrolling would be, if I go back to the sample and I add 50 again, instant scrolling would be, if I click right here, then just go to there. Like, immediately do that. If I click here, go right to there, instead of doing this. Instead of going in pages. I want to support instant scrolling, and I want it to be able to do a smooth version of itself and a truly instant one frame version of itself. And by the way, we've already got that basic functionality. And scrollable. If I go to smooth scroll, and I set it to false, then I should have just turned off smooth scroll, and so now there's no smoothing. It just goes in a single pixel to the place that you click. So starting at 0, 8's at the bottom, click it down, now 8's at the top, 15, click again, 15 to 22. This is the same system without the animation working. Hang on. What did I just see there? Don't double jump. It's another little bug that I've got noted somewhere. If you click too fast on these things. So we're at 42 right now. I click again. No, that's right. The gap was correct. I was just double checking. But yeah, so this is the system without any smoothing to it. And so you see how important it is to do a little bit of work, animating. Because the difference is that. Just by adding in 60 frame per second interstitial animations. So that is what is on the agenda for today, and the fact that I took all of that time explaining it to you feels like it's I've earned a live stream break. This is a lot of talking and a lot of thinking, and and I have multiple times in the course of just giving you guys this explanation of this first hour, I've multiple times like sat here and had to like close my eyes as I was talking and just try and steady myself. It's a lot to be using all of this air with my disease, while also trying to use my brain. I gotta keep the brain oxygenated, and to be yammering at 100 miles a minute deprives the neurons of the energy that they need, the combustion, the fuel. So let's have ourselves our first live stream break after the first hour of the live stream here. When we come back, we'll actually try and do some code today, huh? What if? So stick with me across this live stream break. Give me a second here to get back to my own desktop. I'm going to play some music for you. I'm going to roll some ads. And it looks like we will start with Mudley Red? Mudley Red. So these are all, like a lot of these anyway, are recordings of me performing songs that either I wrote or I performed, covers, all kinds of mixes in there. I'm going to play some music. We're going to go to break. 7 minutes. Opportunity to grab a drink, grab a snack, meet me back here. Don't go anywhere. Pawn not out.
Come a link from Lynch and leisurely, the lesions of a gnome, and now we're needlessly nostalgic for that nepotism's home. Instead of swinging from a tree, you're now defiled on TV, where reporters who have known your name for hours, totaling 3, will paint your life, your love, your lament on a canvas made of dirt. Welcome to the media age. Wish we could turn back a page, don't you? Oh, it's just a media age. Wish we could turn back a page or two. And on the nightly news, you watch them choose the stories fit to print. Well, they got a formula for butcher pile. They just bake 2 pounds of shit. They know all the game to play, all the name to say, how to make sure you stay tuned. With stories and more to live, and if you're just tuned into the nightly news, this is the media age. Welcome to the media age. Wish we could turn back a page. Oh, it's just the media age. They got contortions and distortions, man. The truth is all, but they call it investigative reporting. But they eat just what the fed, then it's secreted, heated, chemically treated, placed on a spoon and gavel seated between the lips, beneath the tongue. Look at America, hiring come from a media age. Welcome to the media age. Wish we could turn back the page. Oh, it's just a media age. Yeah. Oh, it's just a media age. Oh, it's just a media age. Oh, it's just a media right.
Hello, I am the Ronan Bond, and welcome back to twitch.tv/RonanBond live stream on twitch.tv/Ronan Bond. Shut up, Kevin. Welcome back to Coding Day, our first in years. Remember when we used to do this? Remember when we used to have coding on the live stream? I was working on Split RP, and I did some Pygame stuff. I think though, instead of using Pygame, I think I used my GUIable just to prove the power of version 1 that we could develop a simple ping pong game on top of my R1, my V1 version of GUIable. This is V2 we're working on today. Welcome to it if you're just joining me. If there's anybody here at all, I have no idea. I would expect very few. For Python Day, it's not Cluster Truck speedrunning. It's not. I'm not speedrunning with the potential to win $1,000 on the line or anything. Let's go into presentation mode. And let's get our structure up and our run box up. And so let's actually stick in. You guys ready to actually tear the Band-Aid off, do some damn coding today? If parent changes, all children must redraw. Get this working, and some things might start working better. Some one-off propagation code might be deprectable. Deprecatable, which is no more a word than deprectable, honestly, but it's closer to a word. No, it would be like this. So where are we going to do that? A parent changes, all children must redraw. Let's head to Skinnable. In Skinnable, you'll see here in the structure, I've got a class that's called the Receivable right here at the top. And the Receivable just makes your it just handles like binding the recipients of a skin to that skin. And then if that skin changes, then all of the recipients get updated. Core skin is the base of the skin class. Receivable is kind of a mix-in, but mix-ins are brittle, and so I prefer anywhere that I can do actual hierarchy in my classes, I do that instead. But I mean, the shape and structure and what it's doing is very mix-inable. But I avoid mix-ins whenever I avoid multiple inheritance where I can. So instead, core skin just inherits receivable. Core skin is the basis of the skin class. Sets up our default values. It provides our access methods for finding out where the images that will be passed into a skin. So a skin is a container for images. It's what enables all of the images here that are being drawn are all packed into skins, and they're associated with different states and that kind of a thing. So this gives us our default access methods, including resolutions, what we can look up. We can look up the BG. We can look up and we can change BG colors and stuff like that. We can reset the whole damn thing, although that's never been used. It's just sort of a theoretical. It exists in there if you need it. We can ask whether or not the thing contains images. Sometimes these are made with just background colors. We can ask whether it's using the background colors. So you can load images into a skin and then say, it's a transparent image that I've put in. I want you to give it a background color underneath the image. And so make it into an opaque, solid, flat thing. Even though the image in it is transparent. So does it use them? You can ask whether it uses it or not, and you can change it here as well. It's a single access point for getter, setter, all of it. We can ask how many states exist, and then we've got some private methods here for whatever's going on there. Now that I've just establishing like some of the basics, so now you understand sort of the basics there. We've got a single skin. It stores exactly one image and one state. And so it's just, the minimal concept. And we've got a color skin, which gives us the ability to make a skin just from colors, no images, just hand in the colors, change the colors, append the colors, all that kind of stuff. So it's a core skin with adding those things. Things get real crazy when you get to the skin class, the proper skin class, where we can make a skin from the paths where you will find the images at, like this, skins, my skin, checkbox enabled. You can pass it in like that. You can pass in the actual images. So if you've already loaded them into a photo image object in Python, you can pass them in a sprite sheet. So a single image that has each of the states in it spaced at a certain rate, you can pass it in here as a sprite sheet. The sprite sheet will break them all up into individual images for you. So there's a lot of weight there. Then there's the dirty skin class, which is it adds tracking to know whether or not a skin needs to be redrawn, updated, that sort of a thing. And you might be wondering, why would you ever need to do that? Well, because we've got another class here called the filter skin. And the filter skin provides a cache and ready view of another skin as mirrored, rotated, or flood-filled in place. Changes to the original skin will be reflected in the filter skin as well. So when the original skin changes, we need to be able to set the images of the filter skin dirty so that they can know that when they are requested, they need to redraw themselves from the original skin first. So that's why you have that. Then we have the bar skin, which I described earlier. It draws a cap, and then a trough, and then another cap. And you can do that vertically or horizontally. Cardinal skin is used to be called button skin and should probably be deprecated. I just haven't deleted it yet because it's got some interesting math in it that I might need again. But the idea was you hand one image in, and then it populates each state with a rotation of the image. So if you hand in an image and you say, this image is facing west. Well, west in our system accounts to 3. We go north, east, south, west. So 0, 1, 2, 3. So this math would put your west-facing image in the west slot, and then it would manufacture every other rotation in the least number of steps, in the least CPU-intensive way. So that's what cardinal skin would do. It's not in use right now, though. So then we got a skin pack, which actually isn't a skin at all. It's just a container for skins. You can hold multiple skins in it, and I've thrown in some methods that you may or may not ever need. I haven't used them yet, but it's the basis for a button pack, which I have used. And the button pack is the same concept as the cardinal skin. It rotates them and flips them automatically for you. You hand in one, and you can get 4 out. But instead of it being images, it's skins you're handing in. So skins contain images, so this will flip and rotate every skin or every image that's in your skin to make another skin that is the same as the first skin except rotated 90 degrees. So that's the button pack, and then we get to the scroll skin, which is again a skin pack that just holds a lot of other skins for the sake of putting the images onto your scroll area, your scroll bars, your scroll handle, and everything. And then we get to the class that we're interested in, the skinnable. The skinnable is a mix-in that provides core skin functionality to GUIable widgets. It requires a sibling class that can make use of after idle for its update method. So the skinnable is actually the basis for all of our widgets. It's as a mix-in, it's what makes it so that we can draw to this, and to this, and to these, and to over here, and to that, and so forth and so on. So, if we're going to do what we said we wanted to do in the to-do class, which is, if a parent changes, all its children must redraw, then we would do it here in the skinnable. We'll see that the skinnable actually has some parent methods where it has a register child method, so when children attach to it, they register themselves, and you can ask it for a list. And so when a skinnable changes, we need to propagate those changes to the children. Right. Okay. So if I go down to the refresh here, I used to call it update, but that overlaps with a term in the library in Tkinter, the main term, update. So I changed to refresh. Refresh runs on instantiation, and when any tracked change takes place thereafter. So this is where we'd want to add in the logic to make sure that all of our children get updated when we get updated. So, should be simple enough. For child in self.children, self. What are we going to do? Let me just look at what we've done here. We have updated our Scratch, we've updated our geometry. Maybe we should make this like... If I make this happen after we've updated our idle tasks. And the thing is, we won't see that this is a method in the IDE because this isn't actually a TK object. It's a mix-in that always mixes in with a TK object, so that's why you sometimes have this, where it's like, what are you talking about? There's no update idle tasks method. If I hovered this, it would be, what are you talking about? There's no update idle task method. But so for every child in self.children, child.refresh. And that should really do it. And then we'll say what we're doing here. Update all, if the parent changes, the children must refresh. And this could be made more complex over time. We could do some math or some, special circumstances to figure out when certain changes are like, well, that didn't change in a way that causes a problem for us. But this should handle it for now, and go ahead and run it, just make sure that everything still runs. I would say it ran a little slower there. It ran a little slower to open because of that. Did you see how that like flashed white at us for a minute? Yeah. And then if I take this out, okay, it's still slow, but the reason it's still slow is actually because of the update idle tasks. See that? Huh. So what I could do instead of forcing an update idle task would be I could do this as a after. TK provides this method self.after. And in fact, it's self.after idle tasks. Is that right? I think that's right. And so that would be, it schedules each of these to happen once we're done doing our thing, which should accomplish the same goal without slowing us down. You see that? I mentioned this at the very beginning of the live stream, that like knowing when to not do an update idle test to avoid that stuff is half the battle with this library. So we just massively increased the performance by not putting that in the way that we had it the first way and doing it this way instead. Whether or not it will still be able to like refresh the children at the correct time and they'll get the correct data, that will remain to be seen. The other half of this would be, so this is on a refresh event, but if our skin changes, then we also need to do this with our children. If there's a change to our skin, so how would I capture that event? The skin itself propagates down to us. If we go back to core skin, we see that if there's a change, we do an update recipients, and the update recipients call does for recipient and self-recipients, recipient.dirty equals true, and recipient.redraw. So we're setting a dirty flag, and that's what I'll need to check then at redraw. That would be a reasonable thing to do. Thing is, I don't think we have a redraw in the skinnable class because, again, this is a mix-in that plugs into the other things there. So I could put that in the place. It's a little bit weird with Skinnable the way that it's a mix-in, that I haven't really found where the edges are. It kind of bleeds between the two of them. But if we go over to widgets.py and we go up to our baseable, this is the base of all widgets. And here's redraw. So if in the base of all redraws we were to say if self.dirty, because that's what we're setting, then for child and self.children, after idle tasks, child.refresh. But will the refresh end up redrawing? Do we override refresh in the base? We don't. And I don't think we necessarily want to redraw like everywhere all the time in refresh, but under this circumstance we definitely do. So I think I might have to add this in too. And then so long as you're not a child of yourself, we shouldn't have a, loop, an unbreakable loop. Still start it up. Performance is exactly the same as I would expect it to do. Alright, at least I have made an effort now to handle this kind of a thing. So let me make a note about what this is. If the skin that this widget uses has changed, all of its children must redraw. Actually, they don't have to refresh, do they? Do they have to refresh? They don't need new geometry. They don't need to consider like that I've got new geometry. They just need to redraw. Here, we just need the redraw. Yeah. If the skin that this widget uses is changed, all of its children must redraw. And then we've got that. So there's going to be a lot of uses of the redraw. And what I would like to do, go back here and go to it again, I would like to just look through them and make sure that I'm not overriding them in a way that leaves that out anywhere. So, child.redraw, recipient.redraw, we're looking for self.redraw stuff, so you. So long as we're supering wherever we're doing the redraw. This is a set skin. Okay, no, I get what that's about. Let's just look for, in fact, it's specifically self.redraws that I want to see. No, you know what I want? I want definitions of redraw. Okay, so we've just got this one in this file. Let's go to scrollable. We have no overrides of redraw there. I'm sure there's a way in the IDE to search for, like, right up under here, maybe even there's like a button to search through the whole thing or something, but I don't know where it is. If you're familiar with PyCharm, let me know. But I'm just going to look in the usual places then. In windowing, do I override redraw? I do. If self.skin.hasImages, self.render, self.skin.image. You know what this is making me realize? I might not even need it where I just put it, because I'm going to leave it there. But backgroundable is, like, there's a difference between the widgets that I expect you to attach other widgets to, and backgroundable is the one, you know? So we need the code, we need it here more than we need it where I just put it in in widgets over here. So back to you. Like, it'll be useful there for where people are using the library in a bad way. But yeah, no, this has to happen outside of that, I feel like. If we have images, then render ourselves, sure. But when it comes to our children... Oh, right, and then self.dirty is we're no longer dirty. We need to mark ourselves like that, or else we'll be doing it forever, is the thing. So back over to widgets. Oops. Okay. So that is an attempt made to cover all of the bases. And because my library is so hierarchical, it's so much based on inheritance, you put it in one place and it distributes to everywhere, to all things. Like, an imageable is a baseable, a hoverable is a baseable, a clickable is a hoverable, a pushable is a clickable, a toggleable is a clickable is a pushable, and then a repeatable is a holdable, and then a draggable is a lone draggable, which is a holdable. So it all goes back down to the base. So this should give us everything that we need everywhere. Let me just look one more time at what we did in the skinning. At the very bottom. If last geometry... So if our dimensions changed, if our this needs to be under that, really. Just the fact that somebody called refresh doesn't necessarily mean that we should fire this off. It should be connected to geometry, and it brings me to what I should have done in the first place, which is just like this. But you've got to come after all this other stuff. So you'd be at the end. So the idea is, if our last geometry is not equal to the new geometry after we get our geometry, we've just refreshed it with the getGeometry method. In fact, it feels like I need a space there. Then, if the xy, which is the 2... this is a slice of an array, and it's just taking the first 2 values. No, this is taking the last 2 values. So if the width and height have changed, then we need to change our scratch file, which is an empty photo image of our width and height that we can draw to, that makes all of the rendering like so much faster by just maintaining one empty image of the correct dimensions that you can access instead of having to create a new image every time. And then if the X and Y has changed, then we need to redraw ourselves. If our width and height has changed, we don't need to redraw ourselves? I feel like if the geometry has changed at all, we need to redraw. Right? If we change position, then we need to redraw because we might need to redraw, like, the background underneath us has changed. If we change width and height, then our own size has changed and the image might fit in us differently somehow or something. So yeah, I feel like we need to redraw in all instances of the geometry not matching. Yeah. And we do the scratch thing first, and then we do the redraw. It all makes sense. Okay. Good. Sorted that out. See, it was a good thing that I came back to Skinnable even though I thought I had it locked down. I think that's good for that. I think we've broken everything, is what I meant to say. Everything is broken now. We've lost the background image for the backgroundable. It's not being redrawn. I don't think that's happening here. I think that might be in windowing. It seems to just be happening on the backgroundables. No, because we didn't change any of this. So, I guess it is back there on the skinnable. What have I done to break this? If we've refreshed, if the last geometry is not equal to the new geometry, then we change the scratch, we update it like we're supposed to, and then we do a redraw, and then we have all of our children refresh. Maybe, I mean, it shouldn't make any bit of a difference, but put it after instead of before. But I'm going to have another look at it. So, what isn't drawing right now is the background did not get refreshed on instantiation. Yeah. So what is the difference between saying, because we used to say this, we used to say, well, let's see what we used to say, actually. By selecting all this and then going to local history, things are so big. Show history for selection. Okay, and then we go back to before I changed anything today. And we look at our self.redraw used to be like this. Okay, I'm going to put it back in the way that it was. Which, I mean, stop. Now I've broken everything even more. None type object has no attribute copy or replace. Oh god. What have I done? Self.geometry equals if last energy 2 is not equal to, then do the self.redraw. This is crazy that I was able to break it like this. It's not a big deal. It'll absolutely fall out in just a second here. It's blowing my mind like why this would matter. You guys didn't refresh either. Is this actually... It wouldn't be. It shouldn't be. Maybe it's that we're doing this. Okay, not that one, but in windowing. Is it something like this where it's because I'm drawing it in a state when it's not quite ready now? No. Is that the one that I already just did? Because I'm going around in circles here, so I'm not sure. I think this is the one that I started with. I mean, maybe I'd need to take them all out to get there. Is there any harm in just... Let me just Control Z all the way back to the beginning of time. On the refresh. Okay. But this is how it was before. And then we go to widgets. And I Control Z to where we started today. We're still broken. And then I go to windowing. And I control Z. And now we're back alive. Okay. And so now we'll go back to skinnable. And we will put it all back. Changes that we made to skinnable. And we're still fine. And that is how I want it. Thank you. And then we'll go back to widgets, and we'll put it back. And we're still fine. And so it's in windowing. Do you want... I don't know why the order of execution would matter here at all. It did matter. Okay, so then if it didn't... Oh, and look, those didn't get updated correctly. If it did matter the order of execution, it's because we're asking the children to redraw before we've rendered ourselves. And that's the whole point of asking the children to redraw, is because we've changed, and we want you to draw the current state of us. So the last state of us that it was seeing was actually before we drew our image to ourselves. Yeah, let's make sure that I'm not doing that foolishly here as well, where the whole point is to draw ourselves first. Yeah, I think that's... If the skin that this widget used has changed, all of its children must redraw. Yeah. So this should be happening after we've drawn ourselves. And then is that an issue in skinnable as well? We do the redraw and then we do ourselves. Okay. I think I've solved that issue. But it has raised some new issues. If I start you up. Okay, now these are back. See? The correct order of execution was really important there. These are back. Everything looks the way that it's supposed to, except for our scroll handles, which have simply not... Scroll has no attribute dirty. Horizontal scroll bar. And who's asking about dirty? Okay, so let's make sure that we do have a dirty everywhere that matters. As a skinnable canvasable, let's just give the skinnables dirty. I would think that they'd already have it, but I guess they don't. So we give the skinnable a variable for dirty. And it might even be fine to make it true to start, because then the first render should clear it all out. And look at that, we're back to this has disabled itself. The bar skins are still drawing weirdly, but at least it disabled itself. We have no handle showing here until I mouse over it. But then when I mouse over it, it does come back to life, and we've still got that issue. But yeah, okay. I think we've accomplished what I set out to accomplish, which was, if we go back to the to-do, if the parent changes, all the children must withdraw, or must redraw. And then some of the code might be deprecatable. I'll look at that. I'll just have to come across it and realize, oh, I don't need that anymore. So we've done that. Fix the bug where repeatable state can remain locked in hover or active. This is observable using the scroll trough, especially page scrolling down a brief delay after page scrolling up. Right, okay, we looked at that earlier. So let's try and fix it now. Repeatable state can remain locked in hover or active. Here's where I think that would probably originate. Hoverable. So right here in hoverable. Hoverable adds the ability to mouse over something and have its image change. So these classes that when you do that, that's being enabled by hoverable. So all these classes that do other things in addition to that, I can drag this one, I can change the state, they all inherit from hoverable. And in order to get hoverable to work for this situation, right there, I'm going to show you. Pay attention, okay? When you come in, just the handle highlights when you come in over it. And now if I take this out and this. Okay, look, hovering still works everywhere. And then when I do this, both the handle and its trough highlight. And then when I do that from within the trough, you see this? You see this weird issue? When you enter from outside of the parent, yeah, you guys can definitely hear that. I don't know what it is. Please bear with me as you listen to that. For some reason, when you enter in from the side like this, you're entering both the parent and the child at the same time. And I guess TK doesn't do, the math to be like, hey, wait a second. You're not entering the parent because you're entering the child. If you're entering both at once, then you're entering both at once as far as TK is concerned. But if you're already in the parent and you enter just the child, then it registers the disconnect. It registers the difference. So this is like this is the kind of nonsense that you have to deal with TK if you're going to, write what I've written. And so in order to make that work, I've put in this code. And now when you enter from the side, all of that happens. The way that we do it is we look through every single child of ourselves. So this will be the trough, is basically searching itself and saying, do I have any children? If I do, if it is also a hoverable, and the mouse is actually over top of my child, then don't do this. Don't set my state to 1. Just return. Just end, because you're just entering the child in that situation. And in order to make that work and not get tangled, I had to then also add to mouse out if our parent is a hoverable and the mouse is also over the parent, then we are moused over and our state should be set to 1. If mouse exits widget into a... Okay, this is for exiting. If the mouse exits the widget into a parent hoverable, set the parent's state. So I set my parent, my master, which, by the way, I am deprecating this language of master and using parent. In fact, I should probably just do Control R and replace all of this right now. Any place that it says master, I've got my own variable that is the same as master, but it's less, racist. It's less, you might be like, master isn't racist. The opposite of master in TK is slave. So the relationship between a parent and the child, the thing that's been attached to the parent, is that it's its slave. It's the master and the slave. And the more I think about that, the more disgusted I am with white people. The guy who wrote this in 1991, 20 years, just 2 decades after the United States of America decided to treat its former slave population as though they're equal, which was, in the founding documents of the nation. Finally decided to make fulfill the promise of the Constitution and of the promise of the end of slavery, and actually, at least on paper, acknowledge equality. That happened in the 1970s. In case you're confused about when it was that black people in America had the equal rights of white people in America, 1970 something. And you can debate when it was, because there were certain states like Oklahoma who were enforcing anti-miscegenation laws well into the 70s. Anti-miscegenation being black people and white people can't get married because we don't want them polluting the master race's genome. That was Oklahoma's take well into the 70s. And honestly, well into the 2000s, because in 2000, half of all white voters in Oklahoma came out to vote to keep that law in their constitution, even though it wasn't enforceable anymore. That's how racist America is. And so while I'm working in Tkinter and I'm seeing the master and slave language, I'm just like, what it makes me aware of is that the person who wrote this lives in such a happy little white European bubble that it means nothing to them. They don't think for a second about how it will impact, like how a coder who happens to be of any color other than white comes to a language and finds the language of masters and slaves built into it. Like, there is just no sensitivity, no historical awareness, no... You're so white. You're so white. You're living in your privilege so deeply that you could stare at this code for the years and years and years of maintaining Tkinter from 1991 on before it became, useless. And never see a problem with slave master language. You could have said parent, child, sibling. You went out of your... It's like, was the person who wrote this library a racist? Like, did they actually want to discourage black people in America? Specifically black Americans who have that direct connection to slavery and apartheid and Jim Crow and all that kind of stuff. Was he actually trying to keep black America out of coding by writing it this way? Or was he just, and I say he and I say white because I just have to assume there's no fucking way that a woman of color wrote this and used slave master. Was the person just so coddled in their swaddling of European whiteness that they never even considered that, these words mean something to other people? Or were they actually, foaming at the mouth racist and wanted to keep the damn blacks out of coding? There's only those two scenarios. Those are the only two scenarios. Either you had no cultural sensitivity whatsoever, no awareness of anyone's experience other than your own in the world, or you're, I probably shouldn't say anything about that guy who got shot. I know people whose accounts on Twitch have been suspended just for being misinterpreted in the in chat as having supported or having said that it's a good thing, and it's like, that's not what I said. I said the person was an asshole. I didn't say that it's a good thing that they're dead or that we should go out and start doing it. I wasn't encouraging violence. I was saying the person was a piece of shit. They encouraged violence in the course of their life. I say I shouldn't talk about it, and then I immediately launch into talking about it. But yeah, so I'm getting rid of the master-slave language, first off, just on general principle, but also because there is a functional purpose. In the IDE, when you're using the master reference within TK, the IDE can't really track that. It's kind of a deep reference within TK, so when you're inheriting from a canvas, and then you're using the fact that a canvas, is a widget, and a widget has a master, and then you write somewhere something.master.something. The IDE can't track that. PyCharm, at least, can't track that deep enough to know what the qualities of the master are. But when you just say .parent, then all you need to do is have the parent here with a definition, if you can give it a definition. In these classes, I haven't, because it's a little bit loosey-goosey at this point. But in certain classes, you can lock down what the type of the parent should be, and then the IDE will know, and then when you say self.parent, it will be able to say, okay, here are the methods of that parent. So there is a functional reason, along with my sociologically sound reasoning. What were we doing? I forgot. I stay so far out of politics. I know about the guy who got shot. I don't know who the guy who got... I don't know his name. I recognize his name from being in the list of, like, you know, radical, conservative, probably a white supremacist with a wink and a nod. And no, I don't hate the Jews. You know, I recognize his name as being in the crowd of those guys. But I know nothing more about it, and probably don't and don't need to at this point, you know. He's not out there spreading hate anymore. So for better or worse, fix bug where repeatable state can remain locked in hover or active. Charlie Kirk, says Jermaine, very heavy on the Trump side of things. Well, if you're a player in Trump's, you know, cabinet, then you're a demon, and you're worthy of the lake of fire. You know, there is a special place in hell for all of the like, these people are an act of violence. The way that they govern is an act of violence upon millions, upon tens of millions, hundreds of millions, upon the entire nation of Palestine. But that's both parties and all candidates in America. But, like, upon the citizenry, upon, like, everything that they do is a horror show. And yes, if there is a hell, then there is a special place in hell and a special room for these people, because they did not go into politics to make things better. They went into politics to get power for themselves, to secure a position, to make them, you know, out of avarice, some kind of desire to be remembered by history, or, you know, like, these people are not there to be the servants of the American people. They are there to be the rulers of the American people and to be celebrities before the world, and they are worthy of a pitchfork, and may he rot and burn in hell, Charlie Kirk. I know enough about him just from hearing people who I trust talk about him to be comfortable in saying, may the man suffer 1,000 years in the fiery depths of that place that Jesus Christ said all of the goats will go. Mason says, Charlie Kirk once said 2 to 3 gun violence events a year is something we need to live with, so we keep the Second Amendment. Well, how'd that work out for you, Charlie? Chuck, how'd that play out? Exactly. I don't know where I stand on the Second Amendment anymore, really. Because it's like, I think I've just gone to a place where it's like, you're never going to get rid of it in the United States of America. And the way that the right, the conservative end of the aisle is so foaming at the mouth and so, like, we're going to arm ourselves and fucking... At this point, I'm almost like, you know what? Yeah, we do need to arm ourselves because the other guys have armed themselves. Like, and you're never going to pry it out of their fucking hands. So leftists and liberals, we need to fucking get armed and get our own militias going and shit like that. Like, there needs to be, for every right-wing conspiracy theory nutter fucking, militia or group of good old boys that get together in somebody's fucking bunker and crack beers and play around with rocket-propelled grenade launchers and shit like that. On the weekends, we need to have an equal group of equal size of leftists who are also armed and ready to meet these fucking psychos if they ever come up out of their bunkers. And honestly, armed and ready to go and do what we need to do to take this country back, because it's gone. It is not in the control of the people of the United States of America in any way at this point. It is the purview. It is bought and sold every election cycle by global and multinational corporate powers and the rich who constitute, 20%, if you want to be generous, of the American public. 80% of the public of this country is living the way that 1 in 5 of us think that we should all live and think is best. Our economy, our economic systems are based on principles that best serve 1 in 5 people while fucking the other 4 out of every 5 people in the ass. That's the country that we live in, and everyone knows it. There's no, discussion. On both sides of the aisle, we are in agreement. You ask a Trump fucking psycho, dipshit, two-tooth backwoods hillbilly redneck 2-digit IQ fucking you ask one of those guys whether or not the American government is under the control of the American people or under the control of corporations and the rich, and they will tell you it's corporations and the rich. You ask a foaming at the mouth left-wing guy like me who controls America, it's the corporations and the rich. You ask the middle class who controls America, it's the corporations and the rich. The lower class, the poverty-stricken, the middle class, everyone but the corporations and the rich are ready and willing to tell you who's running this fucking bitch. And somehow we got 280 million people who just can't be asked to get up and do what needs to be done, apparently. Right? It's in a country of 350 million. Something like 280 million of them all know that our lives are being dictated by an investor class who made their money by being, wolves, by being soulless husks of human beings only concerned with what they can get for themselves out of this moment, whose romantic relationships are as treasures to be held and as trophies to be shown before one another. And look at how many things I own, how many cars I own in a building just to hold all of my cars. Ah! Jerry Seinfeld, what a cunt, right? He owns a fucking building in Manhattan or something to store his vehicles. Jay Leno, what a fucking cunt, right? Like, these pieces of shit, these dregs of humanity, these bottom feeders of society who have not been evolved away quite yet, who have no emotional capacity for another person's suffering or another person's situation, who are just out to get whatever they can get for themselves and burn anyone down who's in their way. Do anything in order to, put themselves in the position to acquire the this or the that, who have no goal in life except to think of themselves as though they are on top of something, to hold all of the money. How did you get the money? What did you do? What valuable thing did you contribute to society? Did you serve anyone? Did you help anybody? Did you live a life that was worth living? What were the adventures that you went on in order to get where you got? Well, I just chased the money every fucking day of my life. That's how I got the money. What do you mean adventures? What do you? I lied and I stole and I cheated and I tricked and I fucked people over. I pushed people. I pulled people ahead of me on the ladder, down the ladder, so that I could use them as rungs of my ladder. What are you talking about? These are the people who run our lives, who dictate and decide what reality we live in, and we all know it. All sides of the political aisle, all the way from one end of the spectrum across to the moderate centrist pieces of shit destroying this country, all the way to the other, side of the mouth foamers. Everybody just sitting there doing nothing. Well, the country has been stolen. It is, and it's just over there too. It's just over there. We could just go over and take it. There's hundreds of millions of us. We just got to get up and walk over and take it back. That's all it needs to happen. But we don't. For some reason. The left in this country needs some guns. And so I don't know where I stand on the Second Amendment, because it would be a wonderful world to live in where we could get the guns off the street, start taking them. At some point, you got to start taking them off the street. Now is not the time, I don't think. I think what I'm finding out as I'm talking to you, here's where I stand on the Second Amendment. We need guns right now. Now is not the time to, say, all right, time to put the guns down. Are you fucking kidding me? Well, the country is in the hands of the corporations and the rich. Now is the time that you want to take the guns out of the hands of the people? I'm in favor of laws that restrict the ability to get a gun and that make you show responsibility and that won't let certain people get a hold of a gun legally. But I think we still need the guarantee that the American people can, even if it's, through illegal means, lay their hands onto weaponry. If you make the majority have to do a dance and a jig and make sure, they prove that they can maintain their weapons safely and all that kind of stuff. License guns the way you license cars. At the very least, I believe it's like 70 or 80% of the country, including gun owners, believes that would be good. That at a federal level, we should have gun licensure as a law. I think that's fine. That's a good place to start. But as a philosophical thing, if you had a magic wand, if I had a magic wand, I would change everything. But if you had a magic wand and the only thing that it could do is remove the people of the United States of America from having weapons, would you wave that wand? At this point in history, the people can no longer have weapons. The government still has weapons. The military still has weapons. The rich are still able to acquire weapons, especially illegally. They can hire people who are military. They can, all that. The rich can do whatever the fuck they want in this country. But the people, the public, you take the guns away from them. If you had a wand that could do it, would you do it? And it's like, would you skew the power to the point where it can never be taken back? I don't know. I don't think so. I think I would put that wand in a safe, and I would, find somebody. It doesn't look like I'm going to be having any children. I would adopt a child, and I would train them to think like I think, and then I would tell them, in 150 years, if shit isn't fucked up anymore, then you can wave the wand, Timmy. But don't you wave this fucking wand so long as, Dow Chemical has more fucking authority at the voting box than the entire state of Massachusetts, Anyway, were we programming? I think we were programming. So repeatable's state can be locked in the hover or the active. and I was looking at the widgets, and I was looking at the hoverable. I just figured out this structure thing, by the way, that PyCharm has this in here, and I used the view mode to turn it into a float, and then, shoved it into this corner here, and it works in both the modes. Like, for presentation, looks pretty good. In this mode, which is where I would usually be coding, fits in nicely. It's just past the line where where you're supposed to... In Python, there's a whole bunch of PEP standards that tell you, like, how you should be formatting your text. And this line decides, like... It tells you where the edge of the printer paper would be. And so I do like to stay within that because I like the idea of being able to print your code and it all fits on the page, kind of a deal. But yeah, this is a really cool tool there. We're going to go back to the presentation mode now. And that means I'm going to have to reopen that window. And, well, we'll open the run window will open itself when it's time. So, where are we? We're in the hoverable. And I think it has to do with this, that we can get stuck. In fact, let's just take this out and see if we can still get stuck. Right? So, the way that we were getting stuck before was I'd click up here, and then here. Here, and then here. Here, and then here. And then here. And I'm not being able to do it, so now I'll undo that. Oh, wait. And now, pull it down, and here, here, and then here. Yeah. So I'm right, probably right anyway, that it's this stuff that's causing it. And it's probably this end of things. How does this relate to mouse in, mouse out? Boom, we immediately got stuck. So... we don't set the state. There's a child in our children, and our get local mouse is here. So let's do this. Let's print Yahoo. All right. And we got Yahoo twice right there. And now if I go this way, there's no Yahoo. There's no Yahoo. There's no Yahoo. And then just mousing down there, I got a Yahoo. And then when I click, we're fucked. Okay? There's no Yahoo going up out of this. But there's a Yahoo when I go down out of it. That's so fucking weird. Can we add another condition to this somehow? If it's a hoverable, you got a child and the child is a hoverable, or a descendant of hoverable, is what's implied there, and the mouse is over that child, Instead of the Yahoo, print me the event. Print me the event, and print me the child's geometry. Event object has no attribute child. What? Oh, comma, not period. Okay, so the event has an X and a Y, and it's a 4714, and then there's a 4848. When we come out of here, we get the X and Y are 3489, and we're at 41 on the Y. So the geometry here is, we're at 41 on the y. So 41 plus 48 would be 89, and the y is equal to 89. And so we are in that moment that we're exiting down, we are still over it. So I'm thinking, like, what if we made it so that it has to be more than, like, if it's equal, then that's not part of it either. It's got, when we're exiting down, it has to be more than. No, it has to be less than 89. So that it's not on the edge. Can we do something like that? Get local mouse currently just returns true. But what we could do is we could compare the event, instead of using get local mouse, we could say exey, event x and event y would be event.x, event.y. I could just use event.x, event.y. Those are short enough. So we would say cx, cy, cw, ch. So this is the child's geometry. It's x, it's y, it's width, it's height. And so if let's do cxw and cyh equals cx plus cw, cy plus ch, thank you. Incredible stuff that the modern IDEs do in terms of, there's a little bit of AI, I think, in here trying to guess at what you're about to type, and it can identify patterns. Whatever is doing this, it can identify patterns, and usually, not usually, I don't want to say usually, it can frequently guess at what you're trying to do there. Very helpful stuff. Also gets in the way at least 30% of the time. At least 20% of the time, let's say. I mean to, you know, it pops up a solution that looks right, and so I say, oh, okay, yeah, no, you got it, and then later I come back to it because I've got a bug, and the bug is that it put the y in instead of the x, like a moron, you know, that kind of a thing. You got to really pay attention to this, what the AI is putting in there, or else it's gonna trip you up. But it can be very helpful. It's more helpful than it is harmful, but it is a little bit harmful. But so the CXW, the idea here is that we're determining the boundaries. You know, we could now have like a B box, and I'm just doing this long form for the sake of you guys, and for the sake of working it out logically. We can now have a bounding box, and we could say that the upper left corner is CX, CY, and then the bottom right corner is the CXW and the CYH. You see? We'll have the actual pixel locations, and then having the CXW and the CYH from this B box, we can say, like, if did I have a point in rect thing? I used to have a method for this. In fact, I might be using it in get local mouse. Yeah, let's check out my utilities. Point. Point overlaps rect. Yes, this is what I'm thinking about. And then get this. The get local mouse actually does all this fucking math. Holy God. So here's what I want to do, I think. I want to use the point overlaps rect instead. That's going to make this... This is very slow. Every time you access WInfo information, it's pretty slow. Like, when you're doing redraws at a rate of 1 every 17 milliseconds, 1 every, that kind of a thing, these WInfo requests, they add up. So let's go back over here. And what if... There we go. That's really cool about the IDE too. If like you've got a utility, if you've got a function in another file that's open in the project and you type a portion of it, PyCharm will find that it exists and it'll start to type it. And if you like let it finish your sentence for you, then it will import it automatically for you. So boom, it just imported it. It added to the utilities imports point overlaps rect. Very convenient stuff once you get used to that it does it. So if point overlaps rect, we take the x, the y, and then the rect. So we've got the b box for the rect, right? And where's the fucking o? And then we could do event.x and event.y for the rest of it. And so this would replace u, is the idea that I'm working on right now. Does that accomplish the same thing? It sure does. It's firing at the same time, but it's doing it without all those WInfo grabs. Let's see if it... It also fires it going up, though, which we didn't used to have a... It didn't used to do that. So now we have the same problem going up as we had going down. And look at how fucking psychotic TK is, right? I've just replaced the way that TK does its math with my own method. And now what we have is a method that's consistent in both directions. We get the same bug in both directions. TK, for some reason, like, it does its math differently when your mouse is exiting upward than when it's exiting downward. This is the kind of shit you have to deal with fucking TK. So this is good, though. We've mastered what's happening here. And now the idea would be, I can go into the VBox, and I can say, -1. Still? It's still firing. Okay. The idea, though, my concept is, we look at these events, and we say, in fact, let's do it like this, because I don't want to see the whole event. I want you to print event X, event Y. The relevant information is CXW, CXH. Okay? CXH is, oh, CYH is what I meant. Those are the relevant pieces. And so 48, 23, 48, 0, 23, what? What? Oh, right, that's the location of the thing, and then the 48 by 48 is the, I got it. So the last two digits there are the area, are basically the bottom right corner of the handle. And then the first two digits are where the mouse is having its event at. So, when I do like this, the mouse's event is at 86 on the Y, and then our dimensions on the Y end at 86. So my idea was, if we subtract 1 from it, which we have done, then that should put our B-box outside. The event shouldn't be taking place inside the B-box anymore. So how is it? 2368 let's look at the B-box. Let's look at the whole B-box again. So, at the moment that we had the event, the mouse was at 2981. Is 2981 within this B-box? And boy, it doesn't look like it is. Like 29 is between 0 and 47, but 81 is not between 33 and 80. So that should be false. That should be false. Am I crazy? Let's look at my my function. Maybe I did the math wrong here. Does the point overlap the rect? Rx, Ry, Rw, Rh equals the rect. And then return the opposite of Rx plus Rw being less than x. So the reason you do it this way is that, like, if this turns out to be true, then we're done, and we don't have to do this calculation. So it's just a slight, savings of a consideration. The y plus the height. Oh, you're ripping it apart. Wait, you're doing it for me. No. No. I mean, no, that's fine, actually. Yeah, that is fine. Then I'm doing all of this work that I don't need to do. Because we don't have to do the B-box. We can just pass the child's geometry. I can literally just do child.geometry. Because it's using the width and height. It's doing all of the additive stuff itself. B-box is not defined. Where did I use B-box? I'm sorry. So I'll still have to extract it and then do a little subtraction, but this should be accurate then. Okay, let's see. So let's go back to B-box equals child.geometry, and then B-box 2 minus equals 1, and B-box 3, so that's the width, and this is the height. We'll just subtract 1 from each of those. God, I can't find the O separate from the P today, apparently. The keyboard is behind the microphone, too, so it's not like I can look at it really while I'm typing. And then we do the B-box. And so this should take the point out of the range. Tuple object does not support fucking item assignment. Yeah. We gotta convert it to a list. Or make our own tuple. Hang on. We need to print the B-box. So 71, 22, and 47. 67, 69. Am I crazy here? So I'm looking at these numbers and I'm saying this is the Y, 22, and we add that to 47. So 57, 67, and then we add the 2, 69, nice. And then you're saying that this mouse event happened at 71, which is, outside of 69. What does points overlap rect actually return? Did I never actually use this function? We return the opposite of. And right now we're returning true when the x is... This is so confusing a way to do this. When you come back to it, it's like, bakes my brain just to have to do. So, the point that was clicked on is less than the X. So it's outside of the X. It's lower than the X, or it's greater than that. So this would be if it's not inside. Or, I presume this would be the same if it's not inside. Then we need to be returning the this. And so now we're not getting the event. But what I want to see now is that if I hadn't done the subtraction, would we be getting the event? Because the answer should be yes. We should be getting the event. And we're not. Alright, that's pissing me off then. Let me use a thing that I know works. Instead of this little function that apparently is untested, instead of using point overlaps rect, let's use rex overlap, and then let's build a fake one. So we've got our B box, that's for our child, and then our M box, which will be the mouse click, will be made of event.x, event.y, and then one width, one height. And so that creates us a single point rectangle. When are we getting the draws? I think this has it working. I'm confused a little bit by some other things that we've got in here. Let's take those out. So under windowing, where were we printing from? Oh no, not under windowing. Under not skinnable. Scrollable. Where's our print? Step list. Let's get the step list out of there. So under what circumstances are we actually triggering this fucking thing? When we come in from the side? No, it worked that time though. It worked entering from the left. It does not work entering from the right. But we're not getting a false trigger there, and we're not getting a false trigger there, and so this works as it should. And the code is preventing us from firing the parent when we're entering from the left. So there's just the right there. Let's check our code in... Where was it that I was doing that? Widgets. Bbox 2. Let's subtract 2 from the width. Nothing there. Working correctly here. Nothing there. It's not working correctly there. Why is that not being caught? Because it's directional. It's working the way you want here, but on the width side you want it to be detected correctly. So we come in like this, and then, yeah, we want it to stop there. We don't want it here, so it becomes directional. But this code would have to propagate for, you know, everything everywhere. So it can't be directional like this. You see what I'm saying? The scroll bar, the handle being stuck in the scroll bar, we want it to be detected as it's entering from here. For some reason, it's not an issue when it's coming in from the top. It's only an issue when it's coming in from the bottom. But if this scroll bar were active, what would our circumstances be? Would we have the similar problem right there? And can I even test that? If I go back over to... Oh, I hate that it does that. Scrollable. And I find some disable stuff. So if I just don't disable when we recalc the handle, then the handle's still here, but I need the handle to be smaller than that. If I just don't do the reconfiguration at all, see? So the problem is, when we come in from the bottom here, or from the right here, how the fuck? It's the right, and it's the bottom. Why would that be the case? Is it because of the size? Is it because of the size of the handle? No, the handles are coming up as the correct size. They're 48s and 48s over here. Yeah, and it's 48, 47 because of what I've done. Gladys. But we solved it on this side by making it subtract by 1. Huh. But because we've subtracted by 1, we lose it here? Is that the problem? Hang on. Go back to widgets. And then let's change you to 0. So now we're not changing anything. And then I go back over to you. Coming from the top, coming from the bottom, left, right. This works fine. Why in the shitting ballsing shit? What? Nandayo? What is going on here? Mata baka ka fueta. What the fuck is going on here? I don't know any other Japanese. So now it's all working. Which would mean what we're doing is this. Right? Just Control V. It's still on the clipboard. Okay. So once I got it off of its own, like, get local mouse operations winfo and put it completely onto my info, we're good now. Like, I don't really need to do anything. What I would like to do, though, is I would like to reduce this down from making a fake rectangle out of the M box into, I would like to get point overlaps rect working. So, this is the kind of nuisanceful math that you just ask a large language model to produce for you, and I'm going to. I'm going to do that live on the stream. Then I have to open up my browser. I don't want to open up my real browser with you people watching. Alright, I guess we're working this out ourselves. We've got an X and a Y, and we've got the rectangle that comes in. And so we just want to see if the X, like, forget the trying to do it smart. Do it longhand, and then maybe you can consolidate. So we want to see if the X is greater than Rx, but less than the Rx plus Rh, right? So X should be, if it's less than that, and it's less than that, then we're good. So if that and Ry plus Rh is greater than Y is greater than Rx, then return... Jesus God, where's my fingers on the keys? Return true. And then what we can actually do is return true if that, else false. Fuck. My left hand I can't see it at all behind the microphone, so I have to feel the keyboard for where we are. Does this accomplish what we're trying to do? So we don't want to use rexor, we want point overlaps rect, and then we can just do event X, event Y, child geometry. Heh. Not quite. It's fucked when it comes in from the top or the left, but it's working from the right or the bottom. And 47.21. It's definitely within there, but when we come in from the right, it's not firing. So we don't see the event. Let's see the events. All of them. So 0, 18. It's because 0 is equal to 0, and 0 is equal to 0. So over here, actually, what I need is if the X is greater than or equal to, and Y is greater than or equal to, and now it works. Yep. There we go. We got it. We got a function going. So now we don't need that, and we don't need that. And return can go up to here. Brilliant. We have solved that issue, and just to confirm, because the actual issue was that, like, when I click up here, and then down here, click up here, and then down here, like, it would get stuck in its old state. But now we're actually using a far more efficient method for calculating this stuff. Wow, is it actually smoother? It shouldn't be. Point, the get mouse thing. Well, when you're clicking in here, yeah, actually, it would have been firing every tick? No, it's only on mouse in, mouse out. Yeah, no. Anyway, we're using a much more efficient method of determining whether the mouse is in or out. And I should use that here as well. So when we mouse out, what are we comparing here? We're saying it's the parent. It's the parent's geometry. Yeah. Sorry you guys can't see that little spot there. I put in self.parent.geometry at the end. Does that still work? No, it doesn't. None-time object has no attribute X. You're talking about event X, and event is none when we mouse out. Ooh. I mean, I could also if event it, but I think this is actually going to be a problem. I think I might just have to use the slower, worse method there. If event... Oh. Okay, that works. I guess my question is, do I need this anymore? Like, it doesn't do the problem there. And then... Yeah, I don't even need that code anymore. It was all to cover problems TK was making, and we've just gone completely around TK. This is beautiful. I love it when that sort of a thing happens. So, yeah, for child and self.show, we check every child that exists underneath us, and if the mouse overlaps the child, if there's... Basically what we're saying is, if there's a child between us and the parent, well, if there's a child between us and the suspected spam caller, well then decline. It might be something else, but we're live on the stream anyway. We're saying, if we have a child that is between us and the mouse, even if TK is telling us that a mouse just entered us, if there's a child between us, then ignore. Don't do the things that we would usually do as though we've been entered. And that seems to have just solved everything for us. It comes in and exits. Beautiful. We solved that bug. Killed another bug, people. That's 2 bugs in... since we've been here. 2 bugs in 2 hours. Hire me today. I like to note what I did. So, replaced, get mouse, what is even it called, in the utilities, get local mouse, replaced get local mouse with point overlaps rect. Yeah, that's enough. Alright, so those are done. And now we get to go on to the fun bit, which is working out the math for conforming our animation thing. I think this will be actually a fun thing to do. Reference point issue for the picture of the arrow up. Hang on. Did that solve that issue somehow? Oh, hang on, I've got to also replace my, I've got to undo the code hack that we did in order to see for testing. Okay, so we're back in here with everything. There we go. Okay, we do still have this bug, which I expect. I think that's going to be something to do with bar skin, and it's going to be a deep dive to figure that out. So, we'll be seeing what the hell that's about. Well, I don't think we'll be doing that today, actually. But we'll see. Maybe. I feel good after what we've just solved there. We have been here. We were here for an hour and we took a live stream break, and now we've been here. It's now been 3 hours. I did not feel that time pass. That's how coding works. I think what I'm saying is I think we need another live stream break. And then when we come back, we get to tackle the fun bit, which is the animation stuff. Yeah. So let's do that then, shall we? Give me a second to get out of all of this nonsense here. So we're going to have ourselves another live stream break. It's a 7-minute break. Gives you an opportunity to grab a snack, grab a drink, take a whiz, leave a bang. Meet me back here in 7 minutes, and we will carry on with our coding. Don't go anywhere. Pawn not out.
I can't explain glacial motion. Oh, why Los Angeles don't drop into the ocean. I can't unravel the layers of mystery or piece together the tragedy of history. 'Cause those lucky suckers, they didn't have to work. Big 3D billboards and big 30-foot smurfs. Everybody wants to be naked and famous. Everybody wanna be just like me, I'm naked and famous. I knew a poet said she didn't like the smell of it, then took her clothes off in a restaurant for the hell of it. I knew a DJ what lived in seclusion. Reality and sobriety were her only delusions. But those lucky bastards, they didn't have to work. Make 3D billboards and big 30-foot smurfs. Everybody wants to be naked and famous. Everybody wanna be just like me, I'm naked and famous. Yeah! Everybody wants to be naked and famous. Everybody wanna be the same as you Everybody wants to be naked and famous. Everybody wanna be the same as you sidewalks, spinning, twisting, blowing up your skirts. Leviathans are walking backwards up your streets, and pleasures only recoil from that hurt. It's just something obscure, something obscure. It's just something and castles, they decide my fate. Then riddling is suggested, take thrice daily. And keep your ADD up off my plate. It's just something obscure. Something obscure. Just something obscure. Something Mr. Flintstone got a bad transmission. Or maybe he just never heard the clutch. Photons hold a secret just like rainbows. My ramblings unrepentant and I'm out of touch. It's just something obscure. Something obscure. Something obscure. Something something obscure. Something obscure. Something obscure. Something obscure. Something 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 obscure. Soft and supple, disguised soul. Pairs and pairs of blissfully listless Levi jeans, and fireworks exploding in a sky full of snow. It's just something obscure. Something obscure. It's just something obscure.
Hello, I am the Ronan Pawn, and shut up. Hello, I am the Ronan Pawn, and welcome back to twitch.tv/Ronan Pawn live stream on twitch.tv/Ronan Pawn. We're coding in Python today. This is, and it's right here. That's my desktop. You shouldn't be looking at my desk. Why are you looking at my desktop? Quit looking at my desktop. Stop it. You don't get to. You're not supposed to know how the magic is made. The sausagey magic. We're in Python and PyCharm, and we're in this mode, presentation mode, which makes it very, watchable. I think. With that open, and then run will pop open when we need it. Okay. So in the first 2 hours, we added this. Functionality, which is that if a parent changes, including if its skin is updated, then all the children will receive those changes. And by the way, what I'm talking about is right here. I'm talking about the GUIable system that I've been writing for Tkinter, enabling transparency, widget child-based transparency, and scrolling. Smooth scrolling, beautiful, 60 frame per second, 120 frame per second. If you set it to do that, I would recommend 60 because you're just pushing it at 120. But this is what we're working on today. It's the only thing we would ever work on Python. Work out the math for conforming the delta. So we're moving on to the next thing. We fixed this, or we implemented this, and we fixed this bug where it's a foundational bug too that was just right down in my at the base of my widget class in the hoverable, which we managed to actually remove code. I love it when fixing a bug actually removes some extra code, and just consolidate it down to a simple test of an existing value of geometry without having to pull the slow winfo information that TK provides from the operating system, from the window manager, I believe is how that works. So yeah, we managed to solve that utterly and entirely. And so putting those aside, we get to go on to what I consider to be the fun stuff, which is working out this animation problem. I described it at the beginning of the live stream. I'll do a quick recap here. The issue is that in order to do an animation for smooth scrolling, like this, you know, where it's just, yeah, baby, it's just moving silky across the screen like that. You know, you need to move the object that you're scrolling, or the objects that you're scrolling, a certain amount of pixels on each movement. And the problem ends up being, if you ask for, say, a movement of 205 pixels, say the scroll to go down is 205 pixels, and you tell the system, I want you to do that in 160 milliseconds, I want you to do that at 17, a frame rate of 17 milliseconds, which is essentially 60 frame per second frame rate. You put all those numbers together, that triangle of numbers right there, bing, 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 you can't get an integer value out of that. You can't guarantee that with all of those variable numbers that you can do the division necessary and end up with an integer. And of course, there's no such thing as a subpixel unless you invent the subpixel and then do easing and blending and you know, kind of weird stuff. We're not doing that here. We need every calculation for an animation to land on a pixel value. And so, the way the system is working right now is when I ask it for a 14 pixel movement across 50 milliseconds, it conforms it to 51 milliseconds, and then, so that there are 3 steps, but then it hands me back 12 pixels worth of movement. It just goes 4, 4, 4. So what we're about to do is implement a system where we can use 2 values in order to take the remainder of any division that left us a little bit over, the result of a mod operation, and put in that many numbers of like the next higher number, so that when we ask for 205, we end up with 205 pixels. There's no amounts of 22s or 23s that you can put together to equal 205, but you can put together 22s and 23s. You can't have just a 22 and 9 of them, or just 23 and 9 of them and hit 205, but you can do it with 22 and 23. So that's how we're going to do our system now. So let's dig in. This is going to start in scrollable, and we're going to need to find the animation stuff. Animation stuff should live under scroll bar, maybe? A lot lives under scroll bar. Scroll bar is the biggest class here in scrollable right now. It's because the way that scrolling works, if we look at the application again, you've got the scroll, like the whole object. We're going to have a whole scroll window. It's going to contain scroll bars and this and a frame and the data that's in it. So all of that is an object, the scrollable. And then you've got the scroll frame, where the objects, the data or the plate, whichever you want to call it, but the data lives here in this viewable area. And then you've got a scroll bar and you got a scroll bar, but then below the scroll bars, you've got scroll buttons, you've got scroll troughs, and then you've got a scroll handle. That's all within the scroll bar. So the way that I've decided to structure this is that the scroll handle speaks up to the scroll trough, which speaks up to the scroll bar as a whole, and the scroll buttons also speak up to the scroll bar, and the scroll bar does a lot of the handling of stuff, and then hands off just a few things like moving the actual content around to the scrollable itself. But most of what makes all of this system work is living in the scroll bars itself. The scroll bar is doing, you know, all the signal handling and a lot of the math and stuff for figuring out what needs to happen. Just how I decided to do it this time. Last time I did it, I actually had the code at a higher level. I don't think I had it stored in the scroll bar. But this means I don't have to like do a lot of fancy linking code where one widget has to register with another and say, "Hi, I'm your handle. Hi, I'm your button. Hi, I'm your this." if the scroll bar handles it all, then anything that talks to it is a child of it, and it's implicit, when you call a function of your scroll bar. Just the fact that you called it has kind of all the information you need in it. So, where's our animation stuff? Starts right here. But actually, we want to go to, not recalc handle. We want to go to, it's called conform? No, Control F, conform. Yeah, conform pixel timings. What do you live under? You're also under the scroll bar. So this is where we're going to be doing the heavy lifting. We want to hand in the amount of change that we want and the duration that we want. And what we want it to return, right now it returns the number of steps and how many pixels per step. We want to return a fully formed animation cycle. So returns P1 P1. No. Yeah, something like that. So conform scroll time into continuous pixel-friendly integer rates by choosing the nearest step size and delay that fit the frame rate and change in pixels requested. So what do we want to do? We want to conform scroll timing to continuous. No. To pixel-friendly integer rates by choosing the most matching, by choosing the nearest millisecond delay to the request. Something like this. I'll probably change this language later too. Nearest millisecond delay. The nearest matching millisecond delay. I'm a very, verbal guy in general, lingual, and so it actually really helps me to take the time to figure out what it is I'm doing by saying it, by stating it, by writing it down in human language. Flowcharts and graphs, but if I just write it down in actual words, that's good for me. So integer rates, by choosing the nearest matching millisecond delay, and then what we're going to do is, so we do that, and then we nearest matching millisecond delay, finding the actually we'll say taking the floored how do you express this? matching today, the nearest matching pixel delta, and using any remainder to populate an extended list of increased steps. That'll do for now, in terms of what we're doing. So, should I just rip everything that we've got out of here? 4 pixel per step in range 1, delta pix plus 1. I don't think that that's going to be a part of things anymore. I'm just going to push that down so that I can think clearly. In fact, we're not going to need that either. So, you've handed in the rate of change and the delay in milliseconds. So, we're going to say that the steps are equal to the delay in milliseconds divided by the frame rate, which we're going to get from the parent. That's where that lives. So now we've got the number of steps, which actually is going to be equal to this. We want the floored value. I keep saying the floored value anyway, but we're talking about the other side of a mod. You know, we're talking about the whole number from a division. So steps is equal to that, and then what do we want to call this? Excess. And look at that. Huh? It's not right, but it's close. Excess is going to be equal to the delta pix divided by, not that, by the steps, I believe. And then what was my language in the to-do? That's going to help me here. I said root delta. So if I just say delta, there are names for this. Like there's the mod value and the other value. Armis Code says how it gonna work when I ask for a prime step. Should be fine. Should be fine. It's about the like division and stuff. We'll test it. But I'll show the numbers. Root is equal to the delta pix divided by the steps. So there's an equation somewhere in math, or in math.something in Python, which I don't think we're importing, where I could get both sides of this in one operation. Fuck it, is what I want to say. It's legible here, but I think this is right. So in fact, let's start by just printing these values. Steps, root, excess is what we're going to get. We're going to start with delta pix and delay milliseconds, and then equals. We'll do like that. In fact, you want to do like that, I think. It puts a space in automatically. Okay, so 208 and 160 equals 923.1. So let's just think that through and work it out. The idea here, can you see my cursor, or do I have to click on it? I think I have to click on it for that to work. Okay, so the idea here is that we asked for a delay of 160 milliseconds. So 160 milliseconds divided by our frame rate of 17 is 9.4. We, actually, the steps, I want to round them. I don't want them to be this. I want it to be this, and then round. Yeah, and if we are using math.round, it means we've imported round. I could use it. Don't worry about it. So, calculator, where'd you go? I always goddamn close the goddamn calculator. Here's a fun thing to do. Now that's on top always. Power toys, baby. Power toys? Power toys. Where is it? Administrative power toys. One of them is you can make any window always on top. But so yeah, We do 160 divided by our frame rate 17. We get 9 back. It rounds down to 9. So we've got 9 steps. And then we take the steps and we say we want 208 pixels. And we want it divided by apparently 9 steps, which gives us 23. But it's 23.1, or in other words, it's 23 and 1/9. 1 over 9. You know, there's a remainder of 1 in our division value, which is what we get from the excess. So that's why we get 9, 23, and 1 out of here. And so the idea is we want to take those values and we want to make a list that would be like this. We want to make a list that will be 23, 2, 3. Right, in fact, let's do it this way. 3, God fucking 4, 5, 6, 7, 8, and then the last one, 22. And in fact, wait, no, you're not 22. You should be 24. 24. What's that? And in fact, we want this reversed. We want it like this because this is my animation concept, is that if we want 9 steps, then we actually want 10 so that we can interrupt that animation with the next request and it'll turn into a continuous animation. That's the idea there. But so we do that, and then the idea is that 23 times 8 plus 124 equals the 208 that we requested over here. Over here. Oh, I must have turned off I closed the calculator and reopened it automatically without thinking or something. Did I do that? Probably. But yeah, that's the whole concept. So this is what we're building toward. So we take the root, which in the instance of what we're doing right now was 9, and then the excess was 1, and then the steps were 9. You were 23, and the steps were 9. Okay? It's just going to help me sort of wrap my head around what needs to happen. So having those steps and that root and that excess. If I want it built like this, so then the animation is equal to, let's say we're going to start with 0, because we're always going to start with 0. And then self.animation.extend. I mean, I would have to build that, and we're not using NumPy, so we can't just like create a thing that has it. So I think I have to use a list comprehension kind of a thing. We'll just do it with a for loop to start. So for I in range of excess, animation.append just root plus 1. Okay? And then for I in range of excess minus, or rather steps minus the excess, animation.append root. And now we print animation and see if that's what I expect it to be. Zero, 24, 2, 3, 4, 5, 6, 7, 8, 9. That's exactly what I wrote down that I wanted here. You guys can see enough of it to believe anyway. If I do clicking just 1 down, we can look at like the other formula that's going on here. Do it again. Oh, it only forms it the one time. That's right. But 0554 It actually did that exactly the way that I wanted to, right? Because we want it to equal up to 14. We asked for 14 at 50 milliseconds, and that equaled out to 3 steps, 4 pixels of change each time, and then 2 excesses. And so we ended up with 2 excesses where we added 1 to it, so 5 and 5 equals 10, plus the original, which is 4, and so we get 14, and this is, boom, I'm done. Holy shit. And so much less complicated than all of that, and we've already, got our result. So, we've got the animation to return now. What the fuck do I do with it? So we're gonna rename this. It's gonna be pixel timings to animations. To animation. So, and then we're handing in a change of pixels and a rate. That's a reasonable thing to call it, I think. And then from now on, we're actually going to hand out the value. And I need to change this because it doesn't do like that. It does 0. And then the P+1s come first because we process it backwards. In case I didn't explain that, the idea is that the fastest way to access a list, which is ostensibly an array, more or less in Python, is to access it from the end and pop. When you pop from a list, you're saying, give me this value back, and then discard that value, which makes the list smaller and smaller and smaller and smaller until it's down to nothing. And so we pack this backwards. So this is the last step that we want to process. And so we line this up, and then every time that we go to animate it, we're going to say, give me this value. Okay, I had that value. Throw it away. Next one, throw it away. Next one, throw it away. Until we get down to here. And that's the fastest way to work with arrays and lists and stuff like that. When you're using them destructively anyway. And now that I think of it, why use it destructively? Because otherwise you have to keep a track of a counter. Yeah, but that's what you should do. Okay. Okay. So then that would mean I could actually gain that, microcosm of speed that no one can even measure in this scenario by making it a tuple instead of a list. The difference between a tuple and a list in Python is that a tuple is read-only once you've created it, kind of. There are ways to set and add to them and whatnot, but it's the fastest iterable data structure, base data structure in Python, I believe, is either a list or a set, either a tuple or a set, but a tuple's faster than a list anyway. So we've got the animation. The reason I'm kind of hovering here and not going to the next step is that I have to break everything at this point. And I guess I just break everything at this point. Now, I could also do this more cleverly, but why would I when it's so legible, right? I could probably do this in a way that's more, I could do it with list comprehension, I could do it in ways, but this is just fucking legible as hell. And the thing about list comprehension, and if you don't know what list comprehension is, I could rewrite this as animation.append root I for, see, it knew what I was going to do. Animation.append root I plus 1 for I in range of excess. And I've just turned this into a one-liner. This is not supposed to be a one-liner. In Python, you would usually have it like that. The problem with list comprehension, the reason why you really want to kind of avoid it, in my experience, except in places where it's in line with another equation and it makes sense, is that once you do it like this, that's the only thing you can do now here. like, you can't inject another operation into this loop. Whereas I can still have this be a one-liner by just doing a regular for loop, for I in like we've got right there. And then if I come back and I'm like, oh, I need something else, boom, I'm ready to add something else. Whereas if I came back to it and it's in this state, then I have to go, okay, fucking for I, and I have to rewrite the whole fucking thing. So it's just less flexible of a way to state the same thing. So as sexy as list comprehension is, in actual like day-to-day use in coding in Python, it's to be avoided. I loved the idea of it. I love one-liners, but this is to be avoided except where it makes so much sense it can't be. It really has to, like, justify itself. So our return is no longer going to be a tuple of, you know, a certain length. It will be a tuple of ints. And I do want it to be a tuple of ints. So I'm going to convert this list to a tuple as it goes out. Yeah, is that how we do that, actually? Can I just say that and then it's continuing? Now, here's the thing. You will see me, while we're coding in Python here, doing stuff like this. We've defined that the change in pixels is an integer, and this is an integer, and we're going to return, that's what this means, a tuple that contains some number of ints. We've just said all that stuff. This works too. Python doesn't give a shit about your typing. So you don't have to declare that what you're going to return, you don't have to declare what kind of value it is. You don't have to say that it's an integer. This is just for the sake of, like, the IDE, which is the development environment. It's this program that I'm working in. It's whatever program you happen to be working in. When you make these definitions, I mean, it'll help, you know, you and the next programmer to understand as well, in theory, but mainly that happens these days through the IDE. This is telling the program that I'm coding in, this is supposed to be an int, and that means the program can, like, warn me when it's not an int, or can tell me it looks like you're returning something that you didn't intend to return, and stuff like that. It's additional documentation is all this stuff is. Completely unnecessary. You do not have to put that in there. Every variable in Python can be of any type at any point. And you can go ahead and use the same variable. You can start the variable out as an integer, turn it into a string, have it flip into a list, make it into a dictionary, switch it back to a tuple, and end on a set. And Python just does it. It just handles all that stuff, which is why it's, you know, slow. It's one of the reasons why it's slow, anyway, in comparison to a compiled language. But it also runs immediately when you click go, instead of having to wait for ages to compile with large programs like Unreal Engine and stuff like that. What am I doing? Well, you just collapsed all this, so now you got to find your usages. And page steps is now going to be equal to... This is actually fine. Yep. We're still going to store it like that, because we're just storing the animation itself instead of the values. I'm pretty sure that's correct in what's being sent and coming back. Yeah, that'll be fine. But so then I want to go to page steps, where it's defined. And you start out as none. I like that. Yeah, that's good. And then you reset to none. That's also good. Yes. What? I think this is a typo. This is supposed to be line steps here. Because this is the function for setting the page scroll delay. And this is the function for setting the line scroll delay, and so at the bottom of this one, you wanna change that. Yeah. We no longer need this. That's going to go away. I think everything else here should probably be good. And then keep me going. If it's none, then, yep, populate it. If you're none, then populate you. And then when we refresh, wipe it out. Is that strictly speaking necessary? No, but it won't hurt. And then page steps equals none. Okay, and now what we want to see is the usage of these guys. Right, okay, so now we're into where the animation actually occurs. We've found our landing point. We've worked backwards to it. So this is where we're first getting these values in order to pass them into the animation cycle. So I think the new meta is going to be just begin animating, and then I just pass in which one I want it to be. So that's when the trough is clicked. When a button is clicked, we want same thing except for with the line steps are just going to pass right into the begin animating. Yeah. And this is now a potential one-liner. I'll leave it. I like the look of the structure. I make the choices whether to have it like that or the other way, depending on how the structure looks. Like, does it look good on the page? So yeah, I think both of those are just fine to do that. And now we need to go to begin animating. And we need to change what you take in. And what you take in is what are we going to call this? It's instructions. So we'll call it instructions, which should be a tuple. And if animating a scroll, just create new steps. New scroll is equal to what? New scroll is equal to not the length of the step list. Right, then self.steplist equals and then for I in range of steps, then we append the things. So this is now going to be a lot cleaner because we're actually just going to do self.steplist equals instructions. Wow. And then if new scroll self.animation step. Okay, now we go into animation step, and this should actually just be fine. The only thing is that this is going to destroy our list. So animation step actually needs to now iterate on it while storing a animation position value. So that would mean if new scroll dot animation
does not compute, does not compute, does not compute.
anim key, maybe? Like, what frame are we on? Anim, I could say self.keyframe. I like that name. It might help other people to be anim keyframe. Not that. Self.anim keyframe is equal to the length of self.steplist. So if there's 9, then the number is 8. So should we do 8? Do we do 8? And then I think we do that. So it's steplist minus 1. Okay. Hang with me and I will explain what I've done when I get to a place where my brain isn't firing so beautifully right now. We're going to set the orientation to the step list.pop. No, we're going to set it to step list keyframe. And then we're going to decrement the keyframe. Minus equals 1. And so now we need to wrap this in like a helper, because we're doing like a for operation that's going to do that. I need to manage this myself. I need to say if self dot, wait, you're saying if length of step list up here. We want to do if the keyframe, self dot keyframe. When we get to 0, this won't run. I think that's okay because our 0 point in the list is a 0. So we don't need to actually draw it. I think that's fine. Yeah. So, the idea behind this system is that when we start a new scroll, we set the starting keyframe to the highest point, the furthest point to the right in our tuple, our list of animation steps, which should be the length of the step list, which will be like if there's 9 values in it, then it'll say that there's 9 values in it. That's the length. But we want to start at the index of 8, because in coding we always count up from 0. So 9 goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, and that's 9 values. So the index we want to use is 8. So we start at 8, and then if self.anim keyframe, when you just say if a value, it checks whether or not the value is none, or whether or not the value is falsy. It's really just whether or not it's falsy, and none happens to also be falsy. By falsy, we mean, is it 0? Is it none? Is it an empty string? Is it there's a lot of different things that are falsy. So this means if the keyframe isn't falsy, if it's true, if it's not 0, if it's 1 or higher, then we're going to run this code. And what we run in this code is we set a move that's going to do on one of 2 axes, either the X or the Y, and we don't know which because we're handing this data in from a point that could be coming from a horizontal scroll bar or a vertical scroll bar, so we have to figure out which axis implicitly by doing this, setting up a 0, 0, and then just writing into one of those 2 positions based on the orientation of the caller. So this is basically telling me, am I horizontal or am I vertical? And so if I'm vertical, I'll write into this position. If I'm horizontal, I'll write into this position. And what we're going to write in there is the current keyframe using the index from up here. So it'll start out as 8, and then after we have used that in our move, we will decrement it. So now it'll be minus equals 1, so itself minus 1. So it'll be down to 7, and then we'll do the operation. The next time the keyframe gets called, which if, right down here, I got to do it again, if self.keyframe, right? If the value after we decrement it is still a value we'll want to draw, which is to say a 1 or higher, then we do the self.after. We call ourselves again, is the idea there. Self.after the frame rate, we call the cycle again. Simple as that. I'm looking at this and thinking that this might want a little futzing. But let's just see how it works. I think this might actually be set up to work now. I think I might be ready to click the button and find out whether or not shit works. I expect, errors and bugs and typos. So our first error is too many values to unpack, expected 2. So what is this in? We match the function delay to the animation rate. No, we don't. Not anymore. Now we just set line steps equal to... Ooh, can it all fit on one line now? It's close enough for government work. It kind of fits on one line now. Lovely. So... yeah, there's probably another couple of those. Okay, wait, it opened without erroring. That's interesting. Nothing explodes yet. Dragging won't do anything because it's not animation-based. Here we go, we're going to try one. Click. Alright, good. Another error. What do we got here? In begin animating, unsupported operand type for tuple and int minus from a tuple. Oh, I put this on the wrong side. It's supposed to be length of u minus 1. There you go. Restart. And... nothing happened. Nothing happened. No errors, though, either. Okay, cool. So let's check out begin animating. Oh, new scroll equals not length of self.step_list. So this needs to be changed as well. This is our way of detecting whether or not we're already in an animation or not, and we're no longer doing the pop thing, so it needs to be based on the keyframe. Yeah. So, new scroll is equal to... anim keyframe. So if we are at 0 on the keyframe, this is hurting my brain for a second here. If we are at 0 on the keyframe, then we would want a new scroll, and so not the bool, you know. Yeah, I think that statement still works. I don't know, my brain's a little bit like, eh. If it doesn't work, then we'll know it didn't work. Go up to... we have animation stuff right here. We've got it. So let's give ourselves the anim keyframe is equal to 0. Starts out equal to 0. Yeah. Alright, let's see if that changed anything. It didn't. Still no animation. That's fine. This is kind of as I expect in the process after I do this kind of a thing. So back down to the animations, and let's see what we've got when we're in here. First off, let's make sure that our instructions are what we expect them to be. Yes. And yes, instructions are coming through exactly how we'd want them. If new scroll. Let me just print new scroll. My brain is still having problems wrapping around this. So it's true because it's 0, it's true because it's 0, it's true because it's 0, it's true because it's 0. It shouldn't be 0, though, then. So print self.anim keyframe. Like after I click it the first time. If I click it quickly. Weird. Print the keyframe. Okay, it's equal to 9. And then it's equal to 3. Let's do this. Let's go into this one and print the keyframe and see if it does, if it... yeah, it goes through the whole list. Good. It's doing the whole thing. Oh, Shimata. Oh, I know. I know what it is. I know what it is. So the issue is when we set the move, we need to do the keyframe of animation times. We need a direction from it, is what we need. And so we would get that direction, the directionality, actually from earlier in the process, is where I used to gather it. And that's why it's not here, is because I used to get it when the button clicked, there's a direction that comes in. And yeah, you see it right there. So we need to bring that in with us into this guy. We get direction there, and then you got direction here, page steps, and direction. So this is whether it should be forward or negative. You know, should it go up or should it go down? Is what we're looking at right there. And to prove that I know, well, I've already put direction in. So, but basically, if I would have clicked on the single line scroll up, that would have worked. But it wouldn't have worked. We wouldn't have seen it worked. So everything was working, except for we need to invert the direction based on the direction. And we weren't able to do that. So this is begin animating that we're calling, right? So begin animating. Oh, wait, no. So this should be direction, and it's an int. And then we pass it through again. Ugh, I hate that. It's ugly. How do you... In fact, no, because the instructions are going to be like that. Ooh. Ooh, ooh, ooh. Do we build the step list every time then? To be either negative, well, to have to flip? Boy, that seems dumb. But we only call this once, so it's like we would have to store the direction. There's a bunch of different ways that I could do this, and I don't like any of them. What we're going to do is we're going to create another, like, parent-held value. And it's going to be, you know, we made this keyframe thing. So self dot anim direction is equal to direction. And then when we do the move, we will multiply by the anim direction. And then up in the init, we'll say anim direction gets initialized to... It really doesn't matter, because it will be set the first time that we used it. Yeah. Okay. And we have scrolling again. Except for this time it's actually like correct in a way that it wasn't before. Now see that that little bit of jerkiness? We didn't have that jerkiness before. You feel it? Oh, this is weird. That one's very weird. This one's still behaving as I would expect. Oh. I get it. So this is the reason why this is having an extra delay in there instead of just being continuous is because we've changed the millisecond delay that was requested, but we haven't updated it in the caller. So the scroll bar is still sending out its requests at a rate of whatever it was that we told it. Still updating its requests. All of this is exactly how I expected it to come out, except for the I didn't foresee this, but the it being a little bit stuttery, that's fine. We're gonna like handle that. But this I didn't foresee coming. This is because the caller sets the rate. Page. Like, where would I look for this? Is it in scrollable? Here we go, yes. So we set the page scroll delay for 160, but then that scroll delay got conformed because it doesn't, add up correctly in that state. So we went from 160 and we did 160 divided by 17 and we found 9 and we said, okay, 9 then. 9 times 17 and we... No, 9 times 17... 9, number 9. I can't fucking see the keyboard. It's underneath the fucking microphone. 9 times 17. So we conformed 160 milliseconds to 153 milliseconds. And so there's a 7 millisecond, gap between what we asked for and what we're getting back. That does not explain our issue. That actually does not explain the issue. If it's delaying at 160 millisecond rate, 153 is well within the 17 gap of a frame, so we wouldn't see this big gap. I don't think you'd see any gap at all because we're still within the 17 millisecond range. So what's causing that? Is the question to ask here. So back to, I think it's scroll bar, and near the bottom, back into the animation step. And let's print the move after we conform it. I hit it once. And we do 1, 2, 3, 4, 5, 6, 7, 8, and then the 9th is the negative 24, as expected, as desired. What is it that I want to see here? Is the question that I have for myself. Wait a second here, I feel like I'm starting to overheat. Little Emmy flareable moment. Give me a minute, or not a minute, but I'm gonna turn a ceiling fan on to cool myself down. Grab another Tic Tac.
Can't touch this. You can't touch this. You can't touch this.
Okay. Coming back. Alright. So we need to, see where this delay is coming in. How would I? Where would I? You could do it in the in the trough itself. No, do it in the scroll bar when the trough is clicked. Right. But how do I get, like, the rate, the time, the amount of time? Oh! Does it have to do with the fact that now that I'm not popping, we should be interrupting it before it gets to the 0? Well, that's something you could test then, maybe. If self.animKeyNum, let's do else print zeroed. Now, when I click this once, we never zero. Yeah, we never zero because we're always... We don't even call for the next animation step if the next animation step would be a 0. Huh. So where is this coming from? It's a good little mystery, isn't it? Yeah, give me the keyframe. Print the keyframe and anything else, the move. Okay, so the keyframe, it's because we subtracted it, so we do go from 8 to 0, but then the 0 never, like, gets... the 0 that's in the... that's in the list, the tuple, we never get to it, which is fine, I would think. But, so let's hold this down and see what we get. So we got what I would expect to see. Yeah, the order of what's being drawn is fine. It's that there's a big fucking delay between the events. I'm gonna go to the trough. And the trough is a repeatable. It's a scroll repeatable. And when you're clicked, you go from the init delay into keep clicking, and then keep clicking uses the delay. And so I want to print your delay. Oh, but this is in keep clicking. So you're saying 160. You're saying 160. We know that ours is 153. Huh. Huh. It takes 153 to move through the 9 steps. We move through the 9. This is what I'm like. This is why it didn't make sense to me. We got 9 steps. We do our 9 steps of animation. That's 153 milliseconds. Then the next time that this thing, fires, is at 160 milliseconds, which comes before the next, frame window of 170. Am I not drawing on the first... That could be it. Maybe I'm not drawing on the first, pass or something. So... Let me scroll bar... Anim keyframe. No. I want functions. Bubblegum and candy. Step to the sweet shop with my sweetheart Sandy. I've been saving pennies, so I'm a sugar daddy. I'm her Hume Cronin, she's my Jessica Tandy. I want candy. Any kind will do. Don't care if it's... Alright. So, if new scroll... then we set our thing and we call animation step immediately. And we do our move. We do the scroll by click. And we send it through. So that shouldn't be the delay. How are we ending up with a delay? Jump in any time, chat. Yeah, no, we're following. When the trough is clicked... I think we gotta sit here in silence and try and work this out, because I'm getting MECFSE. I'm getting, brain swollen. So let me just sit with it a little bit. Let's actually give ourselves a lot more steps to play with. Are the steps correct, by the way? Yeah, they're still good. It's still nice and smooth. And it even works here. Well, let's, consider taking out the 0. Here's my conform. Oh, yeah. Change the name. So I start with animation equal to 0. What I could do is start with it equal to the root, and then for I in range of... Oh, that would be a little bit actually tricky. If there's an excess... Okay. Root plus 1 if excess. Else root. Yeah. And then we do the amount of excess minus 1. But if there's no excess, yeah, see how this, like, breaks it? It makes it a little bit more complicated. If I just don't put anything in it, and then we do... This should, like, skip a step. Oh, gee. Oh, well, that was just to load the 300. Yeah, that... Whatever's going on now... It's pretty much the same. But, it should be, like, skipping a step, I think. Show me what it is. All right, 5, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. It's still 9 steps, so it's what we want. And then all right. The problem then would be that this will chop one of the steps off. So if we print the keyframe, we should see one missing. 7, 6, 5, 4, 3, 2, 1, 0. There are 8 steps. Well, because 8 has already been turned into 7, but then the 0 never happens. So you see, we do have 8 steps showing, but really what we're doing is if I just move this up, it would be less. Like, what? If I just put it up here, then we'll see 8 down to 1 instead of 7 down to 0. Yeah. And then the 0th one isn't actually happening. So we would have to say... if self.anim keyframe is less than 0, or no, is greater than 0, no, greater than or equal to 0, then do this, and then you as well. Oh, that's right there. That was the problem. Right there. So at this point, I've already subtracted from negative. I've already -1 to the fucking thing, which means that it was it wasn't drawing the last step. You see, this is where it actually gets drawn, or this is where we actually call like the last or something. Like this test was maybe that's the problem. Maybe it's not. Shit, I thought. But listen. Just run the thing. Uh-oh. Put this back in. In fact, put it above this. Because we are going to probably have locked ourselves out with negatives. We've gone negative. And then it stays negative. Why would you stay negative? If new scroll... if we call begin animating... I don't think the new scroll thing needs to exist anymore. Okay, no, it needs to exist for the sake of that. but the keyframe, if you're calling for a new animation, always needs to reset. Yeah, that shouldn't be underneath that. Bruh? So it's because of the test now. We can never get a new scroll because it's gone to -1. So, new scroll... Right. Is it that we want to test whether it's less than 0 at this point? Because the true end is -1, and then that would be a new scroll. So basically, if it's equal... In fact, I could just say if it's equal to -1. What? New scroll is equal to -1. You can see my brain starting to struggle. This will be the last thing that we solve here on the live stream. Once we get scrolling working, that'll be time to, you know, clap ourselves on the back and celebrate for the day. So if that's going to be that way, then I need to go to where we define this in the init and set u equal to -1. And we are now able to continue scrolling. I'll just fix that for you. And now if I hold it, we get continuous scrolling. Huzzah! We are back online. And it looks fine to my eye. Like, you can't tell that there's a little bit of a 24 to 23. You can tell here. You can tell that, you know, there's a little bit of a there. And so that's just a matter of picking a magic number. I wanted my system... You know what? Let me back the fuck up. One. What? Back the fuck up and explain what you just solved. How you solved this. Okay. So... let's just walk through the steps here. In begin animating, we made it so that the end of an animation is -1 by getting rid of the extra and unneeded slot in our animation instructions, in our list of animations that come through. We dropped the 0 that was displacing everything one forward, which was kind of elegant, and honestly, I could go back to that, because it was so elegant. It was so elegant! Are you kidding me? But so, we test to see if we're sitting on, you know, if there's no scrolling going on right now. If there's scrolling going on right now, then the keyframe will be higher than -1. If it's anything higher than -1, then there's a scroll already going on. So we set that value first, because we're going to change the keyframe, and we need to be able to, like, reference that after we've changed the keyframe. Then we populate our step list with the instructions, like usual, depending on whether or not it's a scroll, page scroll, or a line scroll event. Then we've brought our direction in. We're going to set that to a value that we can test in the other function without having to pass it through, because it's a function that iterates itself, and so that would be kind of brittle to have it, like, carrying a thing that it keeps handing to itself over and over again. So we're just going to store that, you know, perpetually in a variable. And then if it's a new scroll, okay, if we were not currently in an animation, then we start the cycle of animation. If we're already in a cycle of animation, then we can rely on the continuing cycle to just pick up the changes that we just made to our keyframe, and we repopulated our step list. You know, it'll just keep going, is the idea there. And in fact, it's really just the keyframe. By moving the keyframe back, the header, it keeps doing that, and then if we're in the middle of it, we move it back to where it started. We move it back to where it started. So we call animation step, we get an animation step, and animation step says if the keyframe is greater than or equal to 0, which I'm just going to say is greater than -1, because we now respect -1 as the end of line. End of line. So if we should still be animating, is basically what animation step is asking itself. Then we set our move variable so that we've got, you know, X and Y coordinates, and then we populate exclusively whichever coordinate it is that we're changing with the value that is in step list at the keyframe, and then we multiply the value that we got from that by the direction, by the anim direction, which is either -1 or 1. So it either just comes out the way it was, or we invert it. And then we call the parent scroll by click, passing across those variables, and then here is where we decide whether or not we need to keep animating. Whether or not we should call ourselves again 17 milliseconds later, which is what this is doing. After 17 milliseconds, call myself one more time, is what that's saying. We determine that by whether or not, again, we are greater than -1. If we're at -1, then that was the end of the animation, and we're just going to, you know, leave it there. Wait a second. If we're greater than -1. Yeah, that's right, because then it'll be 0, and then we'll subtract one more time. No, this is different. If we're greater than or equal to 0, like, should I be doing that? This is, I think I might have an extra cycle in here that we don't need. If the keyframe is greater than or equal to 0, and I can state this is the same thing. You're saying the same thing. If it's greater than -1, so if it's 0, then we're going to run it one more time. We shouldn't. We shouldn't run it one more time, I think. I want this to be if it's greater than 0. Because if we're at 0, and we haven't, like, decremented again, then that was the end. We did the last keyframe, and it was 0. There's no -1 keyframe, so we shouldn't call again. So I think it's just luck that we weren't, you know, causing a problem here. Let's see if things still work. Yeah. It was just like timing that was keeping that from not fucking up. In fact, does that help the scroll look better? Single scroll, looking smoother. Look at that. You see? Do you see? And it is actually changing, like, speed, though. We know that it's changing speed, but we can't see it with our human eyes. That's so fucking cool. Where am I? Where's this print coming from? It's coming from up here. What I want to print is up here. Let's print the step list. Okay. So, look at that. We're going 554, 554, 554, 554, 554. And I can't really tell that there's jitter in there with my eyes. It looks pretty friggin' fluid. However, okay, if you don't like this, you think the idea of having a 554 animation in there is a problem, I started to say this before, and then we went through the whole, like, explanation. I wanted my system to be trustworthy. When you say that you want 14 pixels of movement, you're going to get 14 goddamn pixels of movement come hell or high water. And even if that means that the animation's going to be a little bit, jittery because you're changing the pixel value in the middle. But if you don't want that, it's just up to you as a developer to find the magic number for the frame rate that you intend to animate at. I intend to animate at 17 milliseconds. Okay? 17 milliseconds. So the animation that we've been doing, let me go find that again. I believe it's under scrollable. It's right here. I've been asking for a 50 millisecond delay, and we've just proved that we conform it and we make what you're asking for. I've been asking for a 50 millisecond delay and 14 pixels worth of movement. Okay. Is there a way that I can conform that so that I still get the 14 with that? No. But what I could do is I could move it to 15 pixels and then it would be perfect. And in fact, let's do that. First off, let's say if we're going to do this at 17, then I'm going to put in the right goddamn numbers, which is 17 times 3 is 51. Okay? And then the delay here is going to be 153, right? Because this is going to be 17 times 9 steps. Thank you. 17... It's under the fucking microphone. 17 times 9 is 153. So we ask for 153 milliseconds and 51 milliseconds. Let's just see that everything is exactly the same when we ask for the perfect numbers. And it sure is. Because we conform to these numbers anyway. But let's go down to where I have asked for increments of 14, and let's change them to 15. 15 should give us 5s when I do this. It's not printing it. Did I take the print out? I thought... Nondayo. Did I take the print out? I thought I had a print in here still. It's under scroll bar. And something down here. I must have mindlessly taken the print out? Is this where I was printing? This is where you were printing, yes. Put it back. Print the step list. Self.step list. So now it's 5s all the way through. Smooth as butter, right? Smooth as butter. Now, back to the 15s. And I'm going to change this to 14 and 14. And... still kind of smooth as butter. I think I can tell the difference on comparison, but if I weren't comparing, like, there's nothing wrong with that. There's nothing wrong with 554, 554, 554, 554 over 555, 555, 555. That is entirely stomachable right there. That is perfectly fine. And look at that. We are back online with smooth scrolling, and what we have done is we have ensured that that you always get you always get back the delta of pixels, the change in pixels that you requested, which was something that I wanted. I just wanted it in there. And since actually it doesn't matter the line widths right now, I'm going to put it back to 15, where the numbers are beautiful and brilliant and wonderful and lovely. And just look at that again. And like, I don't know that I can tell the difference, really, because there's like a little bit of kind of jitter stutter, maybe like weird like the kind of, as a speedrunner, I can sense like I can smell a little bit of my inputs aren't getting there, they're getting eaten on the 112th frame. But that's the difference between 555 and 554 is really hard to tell. I'm happy with what we did today, and I think we've handled all possible scenarios in the best possible way. Let's go back to the to-do list, because what we did today is we took out this. All the parent changes get, updated into their children. We fixed the bug where there was like there was a hover problem here, where it could get stuck in a state. And now what we've also done is all of this. I could go through here for a while and mark all of these guys. Here's what you do. You go like that. Like that. That. And like that. I do like to do this because I keep a log of everything that I've done. Everything that I intend to do and everything that I've done, I have logs of. So I am going to keep a log here of all this, and this is actually the alternate version that I'm not even going to fuck with because the results are good. So here's what we do at the end of the day. This is how you motivate yourself to keep going on a big project. Those are all the things that I worked on today, and now I'm gonna scroll down to where I keep the done list. Okay. And I'm going to find an appropriate spot for this, which is actually just right here. This is fine, because it's a big job. It can just go right in. And these are all the things that we did today. We'll back that up by 1. That's everything that we did today. And so what's left to do is figure out why Barskin is behaving so badly. And implement instant scrolling and smooth scrolling. These are the next 2 big items on the list. But in terms of what's to do in the project, I'm wrapping up on the scrollable rewrite. We've got scrolling working. It is working. It is stable. This is everything that I had left to do in scrolling, and a lot of it is done, or is kind of just describing things that have already been done, kind of a deal. But yeah, see, we got things that are marked as completed in this list. After that, I got some bugs to handle here. In fact, the bug that we handled today, scroll trough gets stuck in active state or down clicks randomly, seems connected to clicking up then down. We took care of that. We took care of that, and even though it's double, I'm going to go ahead and put it down here, because it's done. And by the way, this is my list of done. Everything that we're seeing right now as I scroll down, these are the things that I have done on this project. That's how you keep yourself motivated and going. So we got some bugs. Naked widget. Is it possible to initiate multiple... Oh, right. Cursor settings. Yeah. Uh-huh. We just did that. The step list doesn't change unless the values that comprise them do. And at this point, I probably have actually cached all the variables that I can think of caching right now, so that goes in the done bin. It's just this is incredibly satisfying to do this. Oh. What's your problem? You prick. To keep your little track of the things that you're doing and the things that you've done. To have a good roadmap in the first place. It's important to have a roadmap, to know where you're going. To have an idea of, your problems, and not to get stuck down on your problems either. You see me logging bugs and then moving on with my life. I'm not going to stop and fix everything the moment that I see that there's a problem. I'm in the middle of another project, I notice there's a bug, or I create a bug by solving another problem. I write it down and I keep going on what I had planned for the day. If we make some assumptions about a scroll handle, we can consolidate, blah, blah, blah. Okay. I think that's enough of looking at the to-do, of managing the to-do list here. The bar skin's behaving so badly. Yeah, I think we should call it a day here. Because what I would do is I would make a test bed. That's what I've written here. My best bet here is to create a bar skin test bed designed specifically to challenge every... And then it trails off somehow, and I don't know what it says after that. Challenge every function of a bar skin, including live expanding. Once I prove that everything works in a controlled environment, I can return to the mess of scroll handling and see if the issues have been solved or are a product of the scroll handling mess. So we've got, this is my core test bed where I prove that everything is working and nothing has broken anything else, and this is where I like to work. But I have other test beds. I have this one, which is simple, and it proves like background colors work when you don't load images in. I also have a scratch area that I don't even know if it will load. Yeah, because I call it the scratch because I'm constantly doing weird things in there. And then I've got the proper scratch, which isn't anything to do with the graphics. It's like doing math and shit and just seeing how things work out. But so I would create a new test bed that's just about bar skins. In fact, let me show you what the sample that we've been working on today. This guy, all this, everything that's working here, these 300 things that we can scroll through, and I got scroll bars, and I got you guys, and I got draggables, and they're saying, where's the one draggable? Give me that. I can move this around, and then come back to it, and it's still there. Hi, how you doing? All of this is right here. And it's a bit of a mess, and it's a lot like of duplication. And it's a lot of stuff that's commented out, not even being used right now. But this, how many lines is that actually? This 130 lines of code spawns this. It gets you this, just 130 lines of code. And I would say probably 20 of those lines can go. Our comments are things that just don't need to be in there, our duplications and repetitions, and old stuff and whatnot. I'm going to turn this back down to something a little bit more reasonable so that it starts a bit faster. But yeah, bar skin will be the next thing because of this bug. And this bug. This is disabled now, but you see how it drew this bar skin in such a way that like the disabled color is here and not here. You know, like these buttons are themselves, they're completely discrete from this trough, this scroll trough that's in here, right? From this. So same thing here. This and this are discrete. This is the trough. And for some reason the trough only draws the disabled color in its minimum space before it got expanded to fill the whole volume. That ain't right either. So there's a bunch of things here with scroll troughs that aren't quite as, or with bar skins that aren't quite right. It could be with scroll troughs when I get in there. Once I prove that the bar skins work, I will either prove that there's a problem with them or I'll prove that they're fine and find out that I'm doing something crazy with with my scroll bars that's causing this. But I think that brings us to the end of the day for programming here. We did a 4-hour, 40-minute live stream on Python, Tkinter. This is, you know, the important part to recognize here in everything that you've seen today is that there are no additional libraries being brought in here. There's nothing. Just make sure that still works. Cool. There is nothing being brought in here. My code is it, and it's not There's no C++. There's no exterior anything. Look at my imports. Tkinter is TK. That ships with Python. Tkinter is part of Python. Everything else is from my own library here. That's in, what are we in right there? We're in scrollable widgets. What are my imports here? There's a bunch of stuff that doesn't need to be in here anymore. That frequently happens. Yeah, that's fine. I'll live with that. What are my imports? Tkinter, TK, enter, time, and typing. These are all part of the library, or part of Python. No added libraries. What else we got? That was widgets. Let's look at utilities. Utilities doesn't have shit, man. Okay, we got some math, and we import square root. Are we still using that? Oh, and git divisors, which we don't need anymore. That was part of, git divisors was part of one of my solutions for the animation that we defeated today. We don't need it anymore. So we can get rid of that import. From Tkinter, we're doing photo image, TCL error, and canvas. And then we got OS and sys for handling some path stuff, and then typing for named tuple, so that we can make this overlap thing. So there's nothing in there. What else I got? Can you see I like looking at my code more than having to actually code my code? The skinnable class, wow, talk about being lightweight. Just Tkinter and then my utilities. That's shocking to me, actually. And then in windowing, we've got Tkinter, time. Why have I got time in here, by the way? Okay, to measure whether we've gained or lost focus. Okay, we do need that in there. And then pieces of my library. And is that it? That is all of the files in my library we've just looked through. Right there. Right there. Bitches. And yeah, that's it. That is it. I'm going to go ahead and bring this back down to the scale that I usually work with it at. I've been doing it at that, larger thing for the legibility of the live stream for you guys, but this is how I'm used to seeing my code. One more look at the program in all its glory. One more review of what we can do here. We've got toggleables that track whether they're true or false as you click them. We've got complete sibling widget transparency supported. We can be over the top of stuff. This is an invisible naked guy that just proves how over the top of stuff we can be. We can be underneath other widgets and we can change them as we go. And now I've lost, I can't pick that up ever again because it's underneath all of these other widgets. I shouldn't have dropped it. We've got obviously hovering, and we've got active clicking. We've got things that you can hold that will fire on repeat. We got things that click instantly. We've got scrolling, where, let me just get that out of the way. We've got scrolling and smooth scrolling, where we do page scrolls like that. Every 153 milliseconds, we land where we started to click. If you hold it down, it scrolls persistently and consistently. It chases the mouse. See, once it's at the place where the mouse is, if I go up, I go up. If I go down, I go down. And I think this is a feature that, more scroll bar systems should have used. Most scroll bars that I interact with don't work like this. But wouldn't you actually use this functionality if it scrolled by page as you did like this? Doesn't this beat the hell out of, clicking in one place and then it just keeps running down, which is the way most scrolling works for some reason? Ugh. So we've got page scrolling, we've got line scrolling. And we've got scroll by drag, where you can just grab the handle and drag it around. We've got a little draggable inside the scroll window just to prove that if you move the draggable somewhere, say up to the number 3, and then you go off screen, you come back, it's still at the number 3. And the reason that we prove that is because every time that anything moves off screen in this system, it no longer is tracked. It gets 41 right now. Item 41 just got moved up here, and it's left there forever. And if I never come back, then they're all just stacking up there. They're not in the places where they were left, which is why it would be theoretically possible for something to go missing or not end up where it's, back supposed to be, but, shake the son of a bitch like you mean it, and, no, it all stays exactly where it's supposed to be. So, I've solved it. I've solved off-screen culling, off-frame culling in Tkinter to achieve a frame rate that TK couldn't possibly support all on its own, especially if it were asked to do what it's doing. What I've got it doing here with transparencies, faked transparencies, blitted transparencies that are so fast you can't even tell. I'm a goddamn, as I said at the beginning of the live stream, I'm a goddamn genius, ladies and gentlemen, boys and girls. If I've never mentioned it before, I am the Ronin Pawn. Yeah. And that was a day of coding, which we were due for. As much as I've been obsessed with this stuff, and I keep talking about it on the live streams, and I keep opening it up at the end of a live stream, the beginning of a live stream, showing you a little chunk of it here, showing you a little chunk of it there. It was probably in all of our best interests that I just take a day and do some coding on the live stream and get it out of my system, right? And then from now on, we don't have to do it together on the live stream. Unless you want to. If you want to, then I would totally like to. What do you mean I gotta go and pull it out?